Hi friends, welcome to Talent Sprint's Banker's Choice program. In this session, we shall discuss an important and interesting topic from quantitative aptitude, that is permutations and combinations. The weightage of permutations and combinations may vary from 1 to 5 marks in different types of bank exams. Before we understand what is meant by permutations and combinations and what is the difference between these two, let us first understand the fundamental principles that are used in solving various questions from this area. These principles are called fundamental principles of counting, and there are two principles of counting. One is principle of addition and the second one is principle of multiplication. Let us first look at what is meant by the principle of addition. If one action can be done in m different ways and another action can be done in n different ways independent of the first one, then either of these two actions can be done in m plus n ways. So as per this principle of addition, if we can do one thing in m ways and the other thing in n ways independent of the first one, then either of these two things or either of these two actions can be done in m plus n ways. For example, let's say we have 5 different chocolates, C1, C2, C3, C4 and C5, and 6 different fruits, F1, F2, F3, F4, F5 and F6. So here you can see that we have got 5 different chocolates and 6 different fruits. C1 to C5 are the 5 chocolates and F1 to F6 are the 6 different fruits. Now in how many ways can we select any one of these chocolates? In 5 ways. Why? Because we have got 5 choices. Similarly, in how many ways can we select one of these 6 fruits? It can be done in 6 ways. Why? Because we have got 6 different fruits, we can pick any one of them. So here a chocolate can be selected in 5 ways and a fruit can be selected in 6 ways. So either a chocolate or a fruit, either a chocolate or a fruit can be selected in 5 plus 6 ways. Why? Because the first action here, as we can see, can be done in 5 ways, second one in 6 ways. So as per the fundamental principle of addition, it should be m plus n ways in which either we can do the first one or the second one. So it should be 5 plus 6, that is equal to 11 ways. So this is one fundamental principle that is used in solving questions from this area. One important point that we can observe here is both the actions that we do here are independent of each other. That is, selecting a fruit is independent of selecting a chocolate. We are not dependent on chocolates when we select a fruit. Similarly, selecting a chocolate is independent of selecting a fruit. So when two actions independent of each other can be done in m and n ways respectively, then either one of them can be done in m plus n ways. Let us now look at the second fundamental principle of counting, that is the principle of multiplication. The statement says if one action can be done in m different ways and the other action can be done in n different ways independent of the first one, then both the actions together here can be done in m into n ways. So here when we have two different actions which are independent of each other and the first one can be done in m ways, second one can be done in n ways, then both together can be done in m into n ways. That is the product of the individual number of ways. Let's take an example to understand this. Let's say from town A to town B there are 3 different routes. That means a person can travel from A to B in 3 different ways. Similarly, a person can travel from B to C, town B to town C in 2 different ways. So in how many ways can the person travel from town A to town C through town B? Now as given in the example, let's say these are the different routes from town A to town B and town B to town C. So we can see that from town A to town B we have 3 routes, route 1, route 2 and route 3. And from town B to town C we have 2 routes, route 1 and route 2. So that is what is given here. A to B 3 ways, B to C 2 ways. Now in how many ways can a person travel from town A to town C through town B? So here as you can see, to travel from town A to town C, the person first has to cover town A to town B journey and then town B to town C. So here both the actions have to be done together. So the first action can be done in 3 ways. There are 3 different routes possible. And the second action can be done in 2 ways. 2 different routes possible. So both together can be done in 3 into 2, 6 ways. So we can say that a person can travel in 6 different ways from town A to town C through town B or via town B. Let us understand what are the 6 different ways. For example, town A to town B, route number 1, and town B to town C, route number 1. So we can say the first possibility here is 1, 1. Route 1 from A to B and route 1 from B to C. Likewise, town A to town B, route 1, and town B to town C, route 2. So 1, 2 is the second possibility. Then similarly we can have 2, 1, 2, 2, 3, 1, 3, 2. So these are the 6 different routes in which a person can travel from town A to town C through town B. Route number 1 from A to B and route number 1 from B to C. Or likewise route number 3 from A to B and then route number 1 from B to C. So these are the 6 ways in which a person can travel from A to C through city B. So this is how the fundamental principle of multiplication can be used to find out the required answer without actually counting the number of ways. As you can see, this is not required to find out the answer. We can simply say the first action here can be done in 3 ways. Second one can be done in 2 ways. So both together can be done in 3 into 2 ways. The principle of multiplication here is applicable not only for 2 actions but also for more than 2 actions. Let's say there are 3 different actions which can be done in X, Y and Z ways respectively. That means the first action can be done in X ways, second action can be done in Y ways and third action can be done in Z ways. Then all the 3 actions together can be done in X into Y into Z ways. Likewise, when there are more than 3 or more than 4 actions, we can simply multiply all the independent number of ways to get the required answer. So the principle of multiplication and the principle of addition that we had discussed earlier are the fundamental principles that are used in solving questions from permutations and combinations. Let us now understand the factorial function, which is extensively used in solving questions from permutations and combinations. Factorial n or n factorial is defined as the product of first n natural numbers and it is denoted as shown here. So n factorial can be taken as 1 into 2 into 3 so on up to n. So the product of first n natural numbers is called n factorial. Remember friends, factorial is not defined for negative numbers or rational numbers. It is defined only for integers, that too positive integers. Or we can say it is defined for whole numbers, that is numbers starting from 0 up to infinity. So factorial of any number n is nothing but the product of first n natural numbers. For example, 1 factorial. 1 factorial is nothing but the product of first 1 natural numbers. So that itself is 1 here. 2 factorial. 2 factorial is product of first 2 natural numbers. So 1 into 2, that is equal to 2. And if you observe, this 1 here can be taken as 1 factorial, or 1 factorial is nothing but equal to 1. So we can say that 2 factorial is 1 factorial into 2, which is again equal to 2. Likewise, 3 factorial is the product of first 3 natural numbers. So 1 into 2 into 3. 1 into 2 is 2, 2 into 3 is 6. And if you observe, 1 into 2 is nothing but 2 factorial. So we can say that 3 factorial is 2 factorial into 3. Likewise, 4 factorial is 1 into 2 into 3 into 4. And again here, 1 into 2 into 3 can be taken as 3 factorial. Why? Because 1 into 2 into 3, the product of first 3 natural numbers is 3 factorial. So we can say 4 factorial is equal to 3 factorial into 4. That is 24. Likewise, 5 factorial is 1 into 2 into 3 into 4 into 5, which is 120. And that again can be taken as 4 factorial into 5. And so on, we can have 6 factorial, 7 factorial up to infinity. So factorial is nothing but the product of first n natural numbers. Now an exception here that we need to remember is 0 factorial. This is an exceptional case where it is equal to 1. 0 factorial should not be taken as 0. Remember, it should be taken as 1. So this is one exception that we need to follow. 0 factorial is equal to 1. And the other point that we have learned here is n factorial is nothing but n minus 1 factorial into n. For example, 4 factorial is nothing but 4 minus 1, 3 factorial into 4. As you can see here, 4 factorial is 3 factorial into 4. So from that we can say that n factorial is n minus 1 factorial into n. Likewise, 5 factorial is 4 factorial into 5 and so on. So this is one point which can help us in finding out factorials very quick. For example, we need to find out 6 factorial. Now we need not do 1 into 2 into 3 into 4 into 5 into 6. That takes long time. Instead, we can simply take it as 5 factorial into 6. And now if you know that 5 factorial is 120, 120 into 6 will give us 720. Likewise, 7 factorial is nothing but 6 factorial into 7, which is 720 into 7, comes out to be 5040. And so on, we can go for 8 factorial, 9 factorial and so on. So this is one very important notation, that is factorial n or n factorial, which is used in almost every question that we solve from permutations and combinations. So you are supposed to be very clear with this particular function, that is factorial n. And it would be very helpful if you can remember up to 10 factorials by heart. So simply write down 1 to 10 factorials on a sheet of paper and make sure that you learn them by heart, so that doing calculations from permutations and combinations becomes an easy task. Let us now understand what is meant by permutations and combinations and what is the major difference between these two. Now permutation as given here is an arrangement which can be done using some or all of a given number of objects. So permutation is nothing but an arrangement which can be done by taking some objects or all the objects out of the given number of objects. For example, the number of permutations of three objects A, B, C taken two at a time are AB, BC, CA, BA, CB and AC. Let's say we have three objects A, B and C. So the number of permutations of these three objects taken only two at a time. So here we are taking only some of the objects, that is only two objects. So the number of permutations that can be done here are A, B. As you can see, we have taken two objects A and B. Then B and C, again two objects. Likewise CA, BA, CB and AC. So there are altogether 1, 2, 3, 4, 5 and 6 permutations possible. So we can say that the number of permutations of three objects A, B and C taken two at a time will be equal to 6. Remember friends, objects here can mean anything. It can be three persons, or it can be three letters, or it can be three numbers, or it can be three books, or three types of different objects, or anything for that matter. Let us now understand what is meant by combination. Combination as given here is grouping or selection, which can be done using some or all of the given objects. So the number of groups that can be made, or the number of selections that can be made by taking some objects or all the objects out of the given number of objects is the number of combinations. For example, the number of combinations of three objects A, B and C taken two at a time are AB, BC and CA only. That means here we have three combinations, that is A and B, B and C and C and A. Remember, we cannot take BA, CB and AC as three other combinations. Why? Because combination is only a group, or it is only a selection. Here AB and BA means the same combination. Likewise BC and CB means the same combination. And CA and AC again means the same combination. Why? Because the group AB or BA is no way different from each other. Again BC and CB is similar to each other. And likewise CA and AC are also similar to each other. There is no difference between the group CA and AC. So here we cannot take AB and BA as two different combinations. It is only one combination. Likewise BC and CB is only one combination. And CA and AC is again only one single combination. So we can now understand that in case of permutations, AB and BA are two different permutations. As you can see here, we have counted them differently. Whereas in case of combinations, AB and BA is the same combination. So we can now understand that A and B, the two letters A and B will give us two permutations, AB and BA, whereas it will give us only one combination, that is AB, or it can be taken as BA. Likewise for the remaining pairs as well, BC and CB here are taken as two different permutations, whereas BC and CB is only one combination. So two letters BC will give us two permutations, but only one combination. And same thing holds true for CA and AC. CA and AC are two permutations, whereas CA and AC is only one combination. So one very important point that we can understand here is, in case of permutations, the sequence or the order is important. Sequence or order plays an important role. Whereas in case of combinations, the sequence is not important. That is, whether you take AB or BA doesn't make a difference in case of combinations. But in case of permutation, AB and BA are two different permutations. So that's the most important differentiating factor between permutations and combinations. In permutations, the sequence has to be followed, whereas in combinations, the sequence doesn't matter. A very interesting and important example which I can quote here so that the difference between permutation and combination can be clearly understood is about a cricket team. Let's say we have 14 players and we need to form a cricket team of 11 players. Now we know that to form a cricket team, we first need to select 11 players who are going to play the match. Now the selection of these 11 players out of the total 14 players comes under combination. Why? Because let's say we have to select two players A and B out of the 14 players. Now whether we select A first or B first doesn't make a difference, because at the end both of them will be present in the team. So A is selected first and then B is selected, or B is selected first and then A is selected, will give us the same combination. That means sequence here doesn't play a role when we are selecting 11 players out of the 14 players. But after the selection of these 11 players who are going to play the match, when we decide the batting order, that is the order in which the players are going to come for batting, comes under permutations. Here, whether player A comes first or player B comes first makes a difference. We can have A first and then B as a second player, or we can have B as the first player and then A as the second player. So very clearly, AB and BA are two different cases, and hence it comes under permutations. Why? Because here the sequence is important, the arrangement is important. It can be AB and then followed by the remaining players, or it can be BA followed by the remaining players. Likewise, when we go down the order, again the arrangement of players plays an important role. So when we decide the batting order, it is a case of permutations. But when we select the 11 players out of the total 14 players, that comes under combination. So the key point that we need to understand here is the sequence or the order. Whenever sequence of objects or the order of objects plays an important role, it comes under permutation. And when the sequence or order of the objects doesn't make any difference, then it should be taken as a combination or selection. So that's the major difference between a permutation and a combination. Permutation is nothing but an arrangement, and combination is only a selection. So we can say that permutation is as good as an arrangement, and combination is only a selection or grouping. Let us now understand how to find out the number of permutations or combinations using the formula. Now, the number of permutations of n different objects taken r at a time is given as npr, which is equal to n factorial by n minus r factorial. For example, as we have seen here, we have got total 3 objects A, B and C, and we have taken 2 at a time. So let us see how to get the answer with the help of the formula. We have total 3 objects and we need to take only 2 at a given time. So the number of permutations of 3 different objects taken 2 at a time should be taken as 3p2, which is equal to n factorial or 3 factorial here divided by n minus r factorial, 3 minus 2 factorial. We know that 3 factorial is 6, divided by 3 minus 2 factorial is 1. So 6 by 1 is equal to 6. And as you can see here, we have got 6 different permutations, 1, 2, 3, 4, 5 and 6. So that is how, with the help of this formula NPR, we can find out the number of permutations of n objects taken r at a time. N factorial divided by n minus r factorial. Similarly, in case of combinations, we can say that the number of combinations of n different objects taken r at a time is given as NCR, which is equal to n factorial divided by n minus r factorial into r factorial. So when we have total n objects and we need to select r at a time, we can take it as NCR. The number of combinations will be equal to NCR, that is n factorial by n minus r factorial into r factorial. Now as you can see here, we have total 3 objects A, B and C, and we need to find out the number of combinations of 3 objects taken 2 at a time. So let's see how to get the answer with the help of the formula. Now as you can see, total is 3 and we are taking 2 at a time. So n is equal to 3 and r is equal to 2. So we can say that the answer here should be 3c2, that is 3 factorial by 3 minus 2 factorial into 2 factorial. Now 3 factorial is 6. 3 minus 2 is 1. 1 factorial we know is 1 and into 2 factorial is 2. 6 by 2 will be equal to 3. So we can say that the number of combinations here will be equal to 3. And those 3 combinations are AB, BC and CA. Hence it is clear that BA, CB, AC cannot be taken as 3 different combinations. Why? Because they are same as AB, BC and CA respectively. So this is how, with the help of the formula NCR, we can find out the number of combinations. The other important point that we can observe here is the formula NCR is equal to n factorial divided by n minus r factorial into r factorial. Now this n factorial divided by n minus r factorial is nothing but NPR. As you can see, NPR is equal to n factorial divided by n minus r factorial. So we can understand that NCR will be equal to NPR divided by r factorial. Why? Because n factorial by n minus r factorial is nothing but NPR. So NCR should be taken as NPR divided by r factorial. So this is the most important concept regarding permutations and combinations. Permutations is nothing but an arrangement of some or all of the given number of objects, whereas combination is only a grouping or selection of some or all of the given objects. In case of permutations, sequence is very important, whereas in case of combinations, sequence doesn't matter at all. Permutations can be given as NPR, that is n factorial by n minus r factorial, where n is the total number of objects and r is the number of objects that we take at a given time. whereas combinations can be given as NCR, that is n factorial by n minus r factorial into r factorial, where again n is the total number of objects and r is the number of objects taken at a given time. And remember friends, the term objects that we have used in case of permutations and combinations can mean anything. Objects can be persons, it can be letters or digits, etc. And whatever be the type of objects, the concept remains same. Let us take the first model from this topic, where we shall solve some basic questions from permutations. That is nothing but arrangement. We know that the number of arrangements or number of permutations of n objects taken r at a time is given by npr, which is equal to n factorial by n minus r factorial. So let's understand where and how to apply the formula npr. The first example here is, in how many different ways can 5 persons stand in a row for a photograph? In how many different ways can 5 persons stand in a row or in a line such that their photograph can be taken? Before solving any question, we first need to decide, is it a permutation or a combination question? And that can be done by checking whether the order or sequence is important or not. So let's see whether sequence is important in this question or not. Now as you can see, there are 5 persons here. Let's say the 5 persons are A, B, C, D and E. And these 5 persons have to stand in a row or in a straight line. So let's say these are the 5 positions, 1, 2, 3, 4 and 5. Now in how many different ways can these persons stand in a row for a photograph is the question there. Now if you try to understand, if first position is taken by A, second position is taken by B and C, D and E, that is one way in which the photograph can be taken. But when first position is taken by B and second position is taken by A and remaining positions taken by C, D and E respectively, that comes out to be a second way in which the photograph can be taken. That means very clearly, when A is in first position and B is in second position, that is one way of taking the photograph. But when they interchange their positions, though the persons remain same, the photograph is considered to be a different one. Why? Because the order in which the persons are standing has changed. So very clearly in this question, the order in which the persons are placed in these 5 positions is important. And hence we can say that this is an arrangement based question or nothing but a permutation. And number of permutations is given by NPR. NPR is equal to n factorial divided by n minus r factorial, where n is the total number of persons and r is the number of persons taken at a time. Now in the given case, we have total 5 persons and all the 5 persons have to be arranged. That means n is equal to 5 and r is also equal to 5. So we can say that the answer here will be 5p5. That is number of permutations of 5 persons taken 5 at a time. That means all the 5 persons have to be arranged. Now 5p5 will be equal to 5 factorial divided by 5 minus 5 factorial. That is equal to 5 factorial by 0 factorial. And hence this can be taken as 5 factorial. Why? Because 0 factorial is equal to 1. So one important point that we can see here is 5p5 is equal to 5 factorial. That means if r is equal to n, then npr can be directly taken as n factorial. So one important point here is, if r is equal to n, then we can directly say that npr should be equal to n factorial. So we need not take it as n factorial divided by n minus r factorial. Simply we can understand that it is going to be n factorial. For example, 12p12 will be equal to 12 factorial, or 8p8 will be equal to 8 factorial. Why? Because denominator will have 8 minus 8, that is 0 factorial, or 12 minus 12, 0 factorial. So this is one very important point, that if r is equal to n, npr will be equal to n factorial. So the answer for this question is equal to 5 factorial, that is equal to 120. So we can say there are 120 different ways in which these 5 persons can be arranged in a row for a photograph. So that is how we can apply NPR to get the answer for number of permutations. But now let us see the other way of solving this question. Here we have solved the question with the help of the formula, that is NPR, n factorial by n minus r factorial. But how to get the answer without using this formula? That can be done with the help of the principle of multiplication. We know that if one action can be done in m ways and the other action can be done in n ways, then both the actions together can be done in m into n ways. So let's see how can we get the answer using the principle of multiplication. If you observe, here we have 5 persons, A, B, C, D and E, and there are 5 positions, 1, 2, 3, 4 and 5. Now let's start with the first position. This first position here can be occupied in 5 different ways. Either A can come, or B, or C, or D, or E can come. That means there are 5 ways in which the first position can be filled. Let's say D has occupied the first position. Now the second position here can be occupied in 4 ways. Why? Because already one of the person has come there in the first position. So now he cannot come in the second position again. So we have only 4 choices left for the second position. So second position can be filled in 4 ways. Let's say C has occupied the second position. Then the third position can be filled only in 3 ways. Why? Because there are only 3 persons left out. Let us say E has occupied the third position. Then fourth position can be filled only in 2 ways. Either A can come or B can come. Let's say A has occupied the fourth position. So this can be filled only in 2 ways. And then last position can be filled only in 1 way. Why? Because only one person is left out. So that person has to come in the last position. So we can see that first position can be occupied in 5 ways, second in 4 ways, third in 3 ways, fourth position in 2 ways, and the last position only in 1 way. And since this arrangement is to be done at a time, we can say that all these actions are being done together. And going by the principle of multiplication, we can say that if one action can be done in 5 ways, other in 4 ways, then both together in 5 into 4 ways. And likewise, it can be extended for more than 2 actions as well. So this altogether comes out to be 5 into 4 into 3 into 2 into 1, which is nothing but 5 factorial. Why? Because this is the product of first 5 natural numbers. And 5 factorial is equal to 120. So as you can observe, that is what is the answer that we have got with the help of formula. So whether we use the formula NPR or we go by this principle of multiplication, we get the same answer. But then this way of solving the problem here is important because in certain questions from permutations, conditions are given. And those conditional questions cannot be solved directly with the help of formula. There we need to go for this way of solution. So the answer for this question is equal to 120. So this is how we can solve a very basic question from permutation. Either we can use the formula NPR, that is n factorial by n minus r factorial, or we can use the principle of multiplication to get the required answer. And the important point that we have seen here is if r is equal to n, then NPR will be equal to n factorial. Similarly, let's say that only 3 positions are available. That means there are 5 persons, but then photograph has to be taken only of any 3 of them. There can be only 3 persons in a photograph. So in how many ways can the photograph be taken? There again we see that total number of persons are 5, but positions are only 3. So here we need to do the permutations of 5 persons taken 3 at a time. And that can be done using NPR, where n is equal to 5 and r is equal to 3. So we can say that the answer is 5p3, which is equal to 5 factorial by 5 minus 3 is 2 factorial. So 5 factorial is 120, 120 by 2 factorial is 2. This comes out to be 60. So there are 60 ways in which 3 positions can be occupied by any 3 of the given 5 persons. And if we try to solve the question using the principle of multiplication, we can see that first position can be filled in 5 ways. Second position can be filled in 4 ways, and third position can be filled only in 3 ways, similar to what we have done in the previous case. Now, since all are being done together, 5 into 4 into 3 should be the answer. 5 into 4 is 20, 20 into 3 is 60. So this again gives the answer as 60. So for all these basic questions, we can use any of these 2 methods to get the required answer. Let us now take the second example from the first model of permutations and combinations, where we shall take up a very commonly asked question in bank exams. Let's look at the question first. How many different words can be formed using the letters of the word banker? So here we have to form all the possible words which can be made with the help of the letters of the word banker. Now as we can see, here we have got 6 different letters, B-A-N-K-E-R. So we need to form all possible words using these 6 letters. Remember friends, in such type of questions, we have to use each and every letter and only once. That means all the 6 letters must be used in forming a word and there should not be any repetition. All these words can be used only once. Now, as you can see here, while forming a word, again we have 6 positions. 1, 2, 3, 4, 5 and 6 positions. Why? Because there are 6 different letters. Now 6 letters, all 6 have to be arranged in such a way that we can get various words. Remember, this again comes out to be an arrangement question. Why? Because as and when the position of the letters changes, the word also changes. So we can say that this is a permutation, and number of permutations is given by NPR. Here n is the number of letters, that is 6 letters, and r is also equal to 6. Why? Because all the 6 letters have to be used in forming a word. So we can say that the direct answer here is equal to 6p6, which we know should be equal to 6 factorial. Why? Because whenever r is equal to n, NPR should be taken as n factorial. That is what we had learned in the previous example. So 6 factorial is the answer, that is nothing but 720. So 720 different words can be formed using the letters of the word banker. Again, if we try to solve this question without using the formula, that is with the help of principle of multiplication, we can say that the first position can be occupied in 6 different ways. That means there are 6 different letters, any one of these 6 letters can come here. So we have 6 choices for the first position. The second position can be filled only in 5 ways. Why? Because already one of the letters has occupied the first position and that letter cannot be used again. So now we have only 5 choices for the second position. Then for the third position we have only 4 choices. Likewise 3, 2 and 1. So altogether we get 6 into 5 into 4 into 3 into 2 into 1, which is again nothing but 6 factorial, comes out to be 720. So again we can see that the question can either be solved using the principle of multiplication or with the help of NPR, that is 6p6, which is equal to 6 factorial. So 720 different words can be formed using the letters of the word banker. Likewise, for a 5-letter word, let's say the word is watch, the given word is watch. How many words can be formed using the letters of the word watch? We find that there are 5 letters here. So 5 letters and 5 positions will give us 5 factorial words. 5 factorial is nothing but 120. So whatever be the given word, simply count the number of letters where each letter is unique and arrange them in those number of positions. So 5 factorial for a 5-letter word, 6 factorial for a 6-letter word, and so on. Let us now take the third example from model 1, which is based on arrangement of digits to form a number. The question here is, how many different 4-digit numbers can be formed using the digits 1, 2, 3, 6, 7 and 9. So as you can see here, we need to form different 4-digit numbers. So we have got 4 positions which have to be occupied. And there are total 6 digits available. 1, 2, 3, 6, 7 and 9. So with the help of these 6 digits, we need to form all the possible 4-digit numbers. Remember friends, again in these type of questions, when he says we have to form a 4-digit number or a 5-digit number using the given digits, each digit must be used only once. There should not be any repetition of the digits. For this question again, as and when the order of the digits in the 4-digit number changes, the number also changes. For example, 1, 2, 3, 6 is one arrangement where the number is 1236. And 1, 2, 6, 3 is another arrangement of the same digits, but the number is different. Now it is 1263. So very clearly, as and when the position of these digits changes, we get different numbers. So order is very important while forming 4-digit numbers. And hence this comes out to be a permutation question, that is arrangement. And we know that number of permutations are given by NPR. Here n is equal to 6. Why? Because we have got total 6 digits. But we need to take only 4 at a time. So R is equal to 4. So the number of permutations or the number of 4-digit numbers that can be formed using these 6 digits can be given as 6p4, which is equal to 6 factorial by 6 minus 4, 2 factorial. 6 factorial we know is 720 divided by 2 factorial is 2, which is equal to 360. So we can say 360 4-digit numbers can be formed using these 6 digits. And again, if we try to go by principle of multiplication, we know that first position can be occupied in 6 ways, second one in 5 ways, third one in 4 ways, and the last one in only 3 ways. So 6 into 5 into 4 into 3 should be the answer. 6 into 5 is 30, 30 into 4 is 120, 120 into 3 is 360. So 360 numbers can be formed using these 6 digits. Similarly, let's say we have to form 5-digit numbers. So there we can say that the answer will be 6p5. Why? Because we have got total 6 digits, but only 5 have to be taken at a time. Or if we have to form 3-digit numbers, then the answer should be taken as 6p3. Why? Because total number of objects available are 6, but we need to take only 3 at a time for a 3-digit number. So 6p3 will give us the required answer. So this is how we can solve questions based on forming numbers using the given digits. Nothing but arrangements, NPR, n factorial by n minus r factorial. One very important point that we can observe from the various examples that we have discussed in model 1 is that objects can be of any type. For instance, in example 1, we did the arrangement of persons in a straight line. So there the object was nothing but the different persons. In example 2, the object was letters of the given word banker. And in example 3, as we can see here, objects are nothing but the digits which are used to form different numbers. So very clearly, when we say permutations of n objects taken r at a time is given as NPR, there the objects can be of any type. It can be persons, it can be letters, or it can be numbers. Whatever be the type of object, the concept of finding out the number of permutations remains same. Either we can go by principle of multiplication or we can use the application NPR to get the required answer. Let us now take the second model from this topic of permutations and combinations, where we shall discuss questions related to arrangement or permutations of similar objects. Let us first understand the statement here. The number of permutations of n objects taken all at a time, where p objects are similar of one type, q objects are similar of second type, and r objects are similar of third type, will be equal to n factorial divided by p factorial into q factorial into r factorial. So as you can see here, total there are n objects, and the number of permutations of all these n objects taken at a time, where p objects are similar of one type. That means there are some p number of objects which are similar to each other. Likewise, q objects are similar to each other of a second category, and r objects are similar to each other of a third category. So the total number of permutations in such case will be equal to n factorial by p factorial into q factorial into r factorial. So whenever we have some objects which are identical to each other or similar to each other, we need to take those number of objects factorial in the denominator. And one point that I would like to add here is, it is not a hard and fast rule that there should be only 3 categories. For example, sometimes there can be only 2 categories of objects. Like there are p objects of one type and q objects of second type. So in such cases, the answer should be taken as n factorial by p factorial into q factorial. There r factorial will not be there. And in some cases, there may be 4 types of categories. P objects of one category, Q objects of second category, R of third category, and S of fourth category. So there again, accordingly, answer will be n factorial divided by P factorial into Q factorial into R factorial into S factorial, and so on. Let us now take the first example from model 2, which is based on permutations of similar objects. Let's look at the question given. How many different words can be formed using the letters of the word? Now here we have got 3 different words. First one is mirror, the second word is banana, and the third one is successful. So we need to find out what will be the number of words which can be formed using the letters of each of these words. Now as you can see in the first word here, we have got total 6 letters. 1, 2, 3, 4, 5 and 6. In general, when there are 6 letters, we know that answer should be 6 factorial. But there 6 unique letters have to be present. Here as you can see, the letter R appears thrice, whereas the remaining letters M, I and O are unique. And we know that whenever there is a repetition, we have to take that number of objects factorial in the denominator. So here the answer should be taken as 6 factorial. Why? Because total there are 6 letters divided by 3 factorial. Why? Because the letter R appears thrice. And since M, I and O are unique, we need not worry about them. So answer can be taken as 6 factorial by 3 factorial. That is 720 divided by 3 factorial is 6. And 720 by 6 is equal to 120. So we can say 120 different words can be formed by using the letters of the word mirror. The second one here is banana, and we have got total 6 letters again, 1, 2, 3, 4, 5 and 6. Now here if you observe, the letter A appears thrice and the letter N appears twice. So how many different words can be formed using these 6 letters? We know that whenever there is a repetition, we have to go for n factorial by p factorial into q factorial into r factorial and so on. Here there are only 2 categories of repetitions. So the answer can be taken as total 6 letters, 6 factorial. A appears thrice, so that comes 3 factorial in the denominator, and N appears twice, so we should take 2 factorial for N. And the letter B is unique, so we need not worry about that. So answer here is 6 factorial by 3 factorial into 2 factorial, which can be taken as 720 divided by 3 factorial is 6 and 2 factorial is 2. So 720 by 6 into 2 is 12. 720 by 12 will be equal to 60. So 60 different words can be formed using the letters of the word banana. So as you can see here, even though there are total 6 letters, we are able to form only 60 different words. Whereas in general with 6 letters we can form 6 factorial words. The reason why we are getting less number of words here is because of repetitions. The point here is, even though we have got 3 A's, and when their relative positions are changed, the word that is formed comes out to be the same. For example, if these 2 A's change their positions, if they interchange their positions, the new word that is formed still remains banana. Likewise, when the N's change their positions, the new word that is formed still remains to be banana. So likewise, we get many cases where though the positions of the letters are changed, the word formed remains the same. So that is the reason we need to divide by those factorial and find out the true answer as 60. Let's now look at the third one here. The word here is successful. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total 10 letters. So 10 factorial divided by the letter S appears thrice. So that gives 3 factorial. U appears twice. That gives 2 factorial. C appears twice. That again gives 2 factorial. Whereas E is unique, F is unique and L is unique. So we can say that the different words which can be formed using the letters of the word successful will be equal to 10 factorial divided by 3 factorial into 2 factorial into 2 factorial. So this can be taken as the answer for the third word here. Remember friends, do not simplify such questions without looking at the options. Why? Because sometimes in the options, the answers are given in the form of factorials itself. So this itself can be taken as the answer. Go for simplification only when a simplified answer like 120 or 60 is given to us. So if simplification is required, you can proceed for the calculation. Otherwise, answer can be taken as 10 factorial divided by 3 factorial into 2 factorial into 2 factorial. So this is how we solve questions when there is a repetition of objects. A similar kind of question can also be asked in case of digits. Let's say we have got 6 digits, 1, 2, 3 and 3, 2, 1. And the question is, how many 6-digit numbers can be formed using these 6 digits? Now in general, when there are 6 digits and we need to form 6-digit numbers, we take the answer as 6 factorial. But again, if you observe here, the digit 1 appears twice, the digit 2 appears twice, and the digit 3 also appears twice. So there are so many repetitions. So we cannot take the answer as 6 factorial. The correct answer should be 6 factorial divided by 2 factorial. Why? Because the digit 1 appears twice. Then again 2 factorial because the second digit 2 also appears twice. And again 2 factorial because the third digit 3 again appears twice. So whatever be the type of object, it can be letter or it can be digits, we need to go for factorials in the denominator whenever there are repetitions. Let us now take another interesting example from model 2. The question says a set of 12 books has 3 identical quant books, 3 identical reasoning books, 4 identical English books and 2 different books on general awareness. In how many different ways can these 12 books be arranged in a bookshelf? As you can see here, the 12 books have to be arranged in a bookshelf. Now because the word arranged is used, it is very clearly a case of permutations. That is nothing but an arrangement. Now as given in the question, out of these 12 books, 3 books are identical quant books, 3 are identical reasoning books and 4 are identical English books. And remaining 2 are different books on the same subject, general awareness. That means here in the set of 12 books, we have got 3 similar books on quant, 3 similar books of reasoning, 4 similar books of English, and remaining 2 are unique books. Why? Because they are different books on general awareness. So this is a case where some number of objects out of the total objects are similar of one type, some other number of objects are similar of second type, and so on. And the answer in such cases should be taken as n factorial divided by p factorial into q factorial into r factorial. So let's see what will be the answer for this question. Now as there are total 12 books, the numerator should be 12 factorial divided by, we know that there are 3 quant books which are identical to each other, which are similar to each other. So divided by 3 factorial. Again we have got 3 identical reasoning books which gives us another 3 factorial and 4 identical English books which gives 4 factorial. Remember, these 2 books are different books on general awareness. So we should not take 2 factorial in the denominator. Why? Because they can be differentiated from each other. Right? Only where the objects are similar to each other, we take that in the denominator. Otherwise, where the objects are unique, we should not take them in the denominator. So here the simple answer is 12 factorial divided by 3 factorial into 3 factorial into 4 factorial. So this is how we can solve questions which are based on permutations of similar type of objects. Wherever there is a repetition of objects, take that number of objects factorial in the denominator to get the required answer. Let us now take the third model from this topic, where we shall discuss questions based on conditional permutations. That is, here questions are given based on permutations along with a certain condition that has to be followed. These questions are quite different from what we have done in model 1. Model 1 was based on simple permutations or direct permutations where no condition is given. But here a condition has to be satisfied and the number of arrangements have to be done. Let us have a look at the first example. The question here is, how many different words can be formed using the letters of the word education such that the word always starts with the letter D? And as you can see here, such that the word always starts with the letter D is the condition. But because up to this point it is a simple question. How many different words can be formed using the letters of the word education? So that's a direct question. We know that there are 9 letters here, so 9 factorial should be the answer. But there is a condition which says the word always starts with the letter D. So here we need to find out only those words which start with the letter D. So how many such words can be formed? Now in general we know that here we have got 9 letters: E, D, U, C, A, T, I, O, N, and we have got 9 positions for these 9 letters. So we can say that without any condition the answer has to be 9 factorial. Why? Because 9 letters can be arranged in 9 positions in 9 factorial ways, and there is no repetition here. Each letter appears only once. So direct answer is 9 factorial. But then the condition here says the word should always start with the letter D. So let's see how to solve this question with the given condition. Now as it says, the word always has to start with the letter D. That means the first position should always be occupied by the letter D. In general, without any condition, we say that first position can be filled in 9 different ways. But because any of these 9 letters can come there. But as the condition says the word should start with the letter D, here we have no choice. That is, the first position should always be occupied by the letter D. That means it can be filled only in one way. There is no other choice. There is no other option. Only D has to come there. So we cannot do anything with respect to the first position. It has to be occupied by the letter D. So there is only one way in which the first position can be occupied. And then the remaining 8 letters can be arranged in any of the remaining 8 positions. And that can be done in 8 factorial ways. So we can say that the remaining 8 positions can be filled in 8 factorial ways. So altogether the answer for this question should be 1 into 8 factorial. That is nothing but 8 factorial. But because one action can be done in one way, the other action here can be done in 8 factorial ways. So both together can be done in 1 into 8 factorial ways. So that's the simple way of solving this question. As the condition says, the word should start with the letter D. So let us fix D for the first position. And that can be done only in one way because we have only one D in the given word. And remaining 8 letters can be arranged in any manner. Why? Because the condition is with respect to only the first position. So we need not worry about the remaining 8 positions. And that we know can be done in 8 factorial ways. So that's why the answer is 8 factorial. Likewise, it can be any other letter in place of D. For example, let's say the condition says the word always starts with the letter U. Again, in that case, the answer will be 1 into 8 factorial. The only point is there, instead of D, we will be taking U in the first position. So that doesn't make any difference in the number of words formed. Answer still remains 8 factorial. So whatever be the particular letter, if it has to occupy the first position, that can be done only in one way. Remaining 8 positions can be filled in 8 factorial ways. And the other important point here is it need not be always the starting letter. It can also be the ending letter. Let's say the question says how many words can be formed such that the word always ends with the letter D. Even in this case, the last position is fixed. That is, it should be always occupied by D. So that can be filled only in one way. But remaining 8 positions, including the starting one, can be filled in 8 factorial ways. Why? Because there are 8 letters left out for the remaining 8 positions. So again, the point to be observed here is it need not be only the starting position. It can be either the starting position or the ending position or any other position for that matter. So irrespective of the position, that is starting position or ending position or middle position or any other position, and also irrespective of a particular letter, that is it can be E, D, U or any other letter, the answer for such questions should be only based on the remaining letters and remaining positions which have to be filled. A similar type of condition can also be given in case of persons. Let's say we have 5 boys and 4 girls who have to be arranged in a straight line. Now in general, 5 boys and 4 girls, total 9 persons can be arranged in 9 factorial ways. But let's say the condition says that the row should always start with a particular boy Amit. That means Amit should always be in the first position. So even in that case, Amit is fixed. That means first position can be filled only in one way. But remaining 8 positions can be occupied in any manner by the remaining 8 positions. So there again the answer will be 8 factorial. And in a similar manner, it can also be asked with respect to digits. For example, we have got 6 different digits and we need to form 6-digit numbers. In general, the answer is 6 factorial. But let's say the condition says the number should always start with 3. That means the first position should always be 3. So 3 is fixed in the first position. It can be occupied only in one way. And remaining 5 positions can be filled in 5 factorial ways. So the point to be noted here is whatever be the type of object, it can be persons or it can be letters or it can be digits or any other object for that matter, the answer for these type of questions can be obtained by fixing the given position with the given object. And then the remaining positions have to be occupied by the remaining objects. Let us now discuss the second example from module 3, where again we shall discuss a conditional permutation. And here the condition is different from what we have done in example 1. The question says how many different words can be formed using the letters of the word education such that the word always ends with a vowel. As you can see, the condition says the word should always end with a vowel. We know that there are total 9 letters E, D, U, C, A, T, I, O and N, and there are total 9 positions 1, 2, 3, 4, 5, 6, 7, 8 and 9. So these 9 letters have to be arranged in 9 positions. In general, without any condition, that can be done in 9 factorial ways. But here the condition says the word should always end with a vowel. That means the last position should always be occupied by a vowel. So first of all, let us find out how many vowels are there in the given word. Now here E is a vowel, U is a vowel, A is the third one, I and O are the vowels. So we see that there are all 5 vowels available in the given word, E, U, A, I, O. Now as the question says, the word should end with a vowel. Here the particular vowel has not been specified. It can be any of these 5 vowels. So we can say that the last position can be occupied by 5 different letters. It can be E or U or A or I or O. Any of these 5 letters can come here. Why? Because all these are the vowels which are available in the given word. So the last position can be filled in 5 ways. Any one of these vowels will come here and the remaining 4 vowels will go for the remaining positions. Now remaining 4 vowels and 4 consonants, altogether we have got 8 letters for the remaining 8 positions. 8 letters can be filled in 8 positions in 8 factorial ways. That is a general permutation again. So very clearly the first 8 positions can be filled in 8 factorial ways and the last position can be filled in 5 ways. And both together here can be done in 5 into 8 factorial ways. Why? Because this action we are able to do in 5 ways and this action here in 8 factorial ways. So we can say that the answer is 5 into 8 factorial. Again here it need not be the last position always. It can be any position which has to be occupied by a vowel. Let's say the question says the word always begins with a vowel. So there again first position can be filled in 5 ways. Remaining 8 positions including the last position in 8 factorial ways. So answer still remains 5 into 8 factorial. And again like vowels, the question can also be with respect to consonants. That means the first position should be occupied by a consonant. So we again find out the number of consonants and those many choices are there for the given position. Remember friends, here the most commonly committed mistake is some students take it as 5 factorial for the last position. That is, because there are 5 vowels, they feel that last position can be filled in 5 factorial ways. And hence they say the answer is 5 factorial into 8 factorial, which is absolutely wrong. Why? Because last position can be filled in 5 ways, but not 5 factorial ways. There are 5 vowels available, any of these 5 can come. 5 factorial should be taken only when there are 5 objects and 5 positions. Here we have only 1 position for 5 objects. So that is the reason we take it as 5 but not 5 factorial. So don't take it as 5 factorial into 8 factorial. It should be 5 into 8 factorial. And like for letters, the similar condition can be asked for digits or for persons. For example, let's say we have 4 boys and 4 girls who have to be arranged in a straight line for a photograph. Now in how many ways can the arrangement be done such that the row always begins with a girl? Now like in the previous example we have seen, the row should always begin with a particular boy like Amit. So that is only one way to fill the first position. But here the question says the row should begin with a girl. So there are 4 girls, any of these 4 girls can come there. So first position can be filled in 4 ways and remaining 7 positions can be filled in 7 factorial ways. And similarly it can be asked for digits as well. Let's say there are 6 digits, 1, 2, 3, 4, 5 and 6, and we need to form 6 digit numbers such that the first digit is always an even digit. So it can be 2 or 4 or 6. That means first position can be filled in 3 ways and remaining 5 positions can be filled by the remaining 5 digits in any manner. So we can say the answer here is 3 into 5 factorial. Let us now take the third example from model 3 where we shall see a condition which is a combination of the conditions given in first 2 examples. Let's have a look at the question first. How many different words can be formed using the letters of the word education such that, now the condition says the word always begins with the letter A and ends with a consonant. So here as you can see there are 2 conditions. The word should begin with the letter A and it should always end with a consonant. So very clearly it is a combination of the condition in example 1 and the condition in example 2. Now let's see how to solve such questions. Now simply as we have discussed in the previous 2 examples, we need to just work on the 2 conditions and then the remaining arrangements can be done in a general manner. Now as it says the word should always begin with the letter A. That means first position should always be occupied by the letter A. So we have no choice but to take A in the first position. That is, the first position can be filled only in one way. So we can say first position should always be occupied by A. So there is only one choice and the first position can be occupied in just one way. And the next condition here says it should end with a consonant. Now here in the given word we have got consonants D, C, T and N. These are the 4 consonants. So here last position can be filled either by D or C or T or N. That means there are 4 possible letters which can come in the last position. So we can say last position can be filled in 4 ways. Remember friends, 4 ways but not 4 factorial ways. Why? Because 4 factorial should be taken when there are 4 positions and 4 objects. Here we have 4 objects but only 1 position. So that is 4p1 or 4. So last position can be filled in 4 ways. So any one of these 4 consonants will come in the last position and the remaining 3 consonants will take any of the remaining 7 positions. So first position can be filled in 1 way, last position can be filled in 4 ways. And we have got 7 positions left out with 7 letters, and that can be done in a general manner in 7 factorial ways. So we can say the intermediate 7 positions here can be filled in 7 factorial ways. So here we have got 3 actions together. So we can say altogether the answer here will be 1 into 7 factorial into 4. That is nothing but 7 factorial into 4. So from this example and the previous 2 examples, we can very clearly understand that for solving questions based on conditions, we first need to work on the conditions and then the remaining positions can be filled in a general manner. So always try to satisfy the conditions first as given in the question and then go for the remaining positions. Let us now take the next example from model 3 where we shall look at a new and a very interesting condition. The question here says how many different words can be formed using the letters of the word education such that the first bit says all the consonants are always together. And the second one here says the letters D, A, O and N are always together. So here we see that the condition is with respect to a set of objects being together. The first one says all the consonants must be together in whatever words we form. And the second one says these particular letters have to be together in whatever words that are formed using the letters of the word education. Now we know that there are total 9 letters, total number of words that can be formed here is 9 factorial. But there is a condition that the consonants are always together. So let's see how to solve such questions. Now here in the given word the consonants that we have are D, C, T and N. Now whenever we want a particular set of objects to be together, what we do is join all of them and consider it to be only one object. That is, here we don't count D, C, T, N as 4 letters. In fact, we will take it as only 1 letter. And the remaining letters are E, U, A, I and O. So altogether we can say that there are 6 objects. 1, 2, 3, 4, 5 and 6. Now we know that 6 objects can be arranged in 6 factorial ways. Let's say there are 6 positions and these 6 objects can be arranged in 6 factorial ways. Now the point here is when we take D, C, T, N as only one object, it means wherever these move, they will always be together. And that is what is required, that the consonants must always be together. So if there are 6 objects, we can say total number of arrangements are 6 factorial. And at the same time, these 4 consonants internally can be again shifted. Why? Because the question only says that consonants have to be together, but order can be anything within the consonants. So here 4 consonants can be internally arranged in 4 factorial ways. Why? Because there are 4 positions and 4 consonants. So total number of arrangements are 6 factorial and internal arrangements of consonants are 4 factorial. So we can say that the answer here will be 6 factorial into 4 factorial. Let me repeat this once again. Whatever objects are to be together, we always join them and consider it to be only one unit. For example, here as you can see 4 consonants, that is considered as only 1 letter. Remaining 5 letters. Total 6 letters can be arranged in 6 factorial. So by doing this, we make sure that these consonants are always together. Why? Because they are connected to each other. They are considered as only 1 letter. Once these arrangements of 6 units have been done or 6 letters have been done, internal arrangements of the consonants can be done. Why? Because consonants must be together. They can be in any order. So that will give us 4 factorial. So total arrangements are 6 factorial into 4 factorial. Likewise, if the question says vowels have to be together, we can say that all the vowels are only 1 letter. So 5 vowels joined together will give us 1 letter. Remaining consonants can be arranged together and then internal arrangements of vowels can be done to get the required answer. Similarly, the second question says how many different words can be formed using the letters of the word education such that the letters D, A, O and N are always together. Now here particular letters have been specified. It is not like vowels have to be together or consonants have to be together. Some set of letters have been given which have to be together. So what do we do? Again join all of them. D, A, O, N is only 1 letter. These are not 4 different letters. It's only 1 letter. Remaining letters are E, U, C, T and I. So we find that D, A, O, N have come together as the first letter. Then remaining are E, U, C, T T and I. So these are the total number of letters. 1, 2, 3, 4, 5 and 6. 6 letters can be arranged in 6 factorial ways. Internally, these 4 letters can be arranged in 4 factorial ways. So again we say that answer is 6 factorial into 4 factorial. Likewise, the same concept can be applied for persons or for digits. Let's say we have to arrange 4 boys and 4 girls in a row. Now total 8 persons can be arranged in 8 factorial. But the condition says all the boys have to be together. So there the 4 boys are joined together. We consider them as only one person. Now 1 person and remaining 4 girls. Altogether we have 5 persons. 5 persons can be arranged in 5 factorial ways. Internally the boys can be arranged in 4 factorial ways. So in that case the answer would be 5 factorial into 4 factorial. Or otherwise the question can be asked in terms of digits. We have got certain number of digits. Let's say we have 6 digits. 1, 2, 3, 4, 5 and 6. And we are supposed to make 6-digit numbers out of it. But the condition is all the odd digits have to be together. That means 1, 3 and 5 must be together. So again we join them, do the total arrangements and then internal arrangement. So whatever be the type of object there, whenever we want certain number of objects to be together, first join all the objects, consider it as only one object. Then do the total number of arrangements and then proceed for internal arrangements. Let us now look at the next example from model 3, which again is a new condition. The question says how many different words can be formed using the letters of the word education such that first bit says no 2 consonants are together and the second one says the letters A and T are never together. So as you can see, this is quite opposite to what we had done in question number 4. There it was all the consonants have to be together and here it says no 2 consonants are together. That means consonants must never be together. Let's see how to work on this one. Now we know that there are total 9 letters, total number of words that can be formed will be 9 factorial. But the condition is no 2 consonants are together. Now whenever we want a set of objects not to be together, we first arrange the remaining objects. For example, in the first question here it says the consonants should not be together. No 2 consonants must be together. So we will first try to arrange the vowels. We know that there are 5 vowels here, E, U, A, I and O. So 5 vowels, E, U, A, I and O can be arranged in 5 factorial ways. So they can be arranged in 5 factorial ways. That means there are 5 vowels and 5 positions, let us say. So they can come in any of these 5 positions and total arrangement that we get with respect to vowels only is 5 factorial. And now we need to arrange the consonants in such a way that the consonants are never together. No 2 consonants are together. So we have to find out the possible places where the consonants can be placed. Now the number of positions where the consonants can be placed are as follows. We can have consonants in this position, here in between U and A, in between A and I, in between I and O and after U. That means we see that there are 6 positions. 1, 2, 3, 4, 5 and 6. So these are the 6 positions where if we put the consonants in any of these 6 positions, we find at least one vowel coming in between them. Let's say we have placed the 4 consonants D, C, T and N in the first 4 positions. So if we consider the first 4 positions, we see that E, U and A has come between the consonants. So they are not together. Likewise, if we take the first, second, fourth and sixth position. So if we take first, second, fourth and sixth position, we find that in between first and second positions there is a consonant, there is a vowel E. So these 2 consonants are not together. Then if we take fourth and sixth positions, we find that between 4 and 6, between these 2 positions, there are 2 vowels, I and O. So again, the 2 consonants that we have kept here are not together. And also, there is a vowel between the consonant at second position and consonant at fourth position. Why? Because U and A will come together there. So the simple idea here is we first need to arrange the vowels and then find out all those possible positions where the consonants can be placed such that they are never together. So here we find that vowels can be arranged in 5 factorial ways, and after that we have got 6 possible positions for the given consonants. Out of these 6 positions, we need to take 4 of them and arrange the 4 consonants on that. So that's like total 6 objects we have, or total 6 positions we have. Out of that, we need to arrange 4 of them at a time. So we can say that the consonants arrangement can be done in 6p4 ways. So the answer for this question here is 5 factorial into 6p4. Let me repeat it once again. Whenever we want the consonants not to be together or any set of objects not to be together, we first arrange the remaining objects. So here the remaining objects are nothing but vowels, which can be arranged in 5 factorial ways. After that, we count all the possible places in which the consonants can be placed. It can be between the vowels and at the extremes. So total there are 6 positions. So in the 6 positions, we can take any 4 positions and arrange the consonants in those 4 positions, and we find that they are never together. Remember friends, when we arrange the consonants in first 4 positions, let's say we have arranged the 4 consonants in first 4 positions. In that case, the 5th and 6th positions are removed. That is like they are not existing there. So I and O will come together. It doesn't mean that 5th position is vacant. It's not like that. These are the possible positions where consonants can be placed. Likewise, when we take first, second, fourth and sixth position, let's say, then the 3rd position and 5th position will not lie vacant. They are automatically removed and letters come together. So don't misunderstand that after taking 4 positions out of these 6 positions, any 2 are left out. It's not left out. Only point is those 2 positions get removed and the letters there come together. So this is how we can do the arrangements when we want a set of objects not to be together. Likewise, it can be asked for boys and girls or for digits. Let's say we have 6 digits and we have to form 6-digit numbers. The digits are 1, 2, 3, 4, 5 and 6. And the question says no 2 odd digits have to be together. So we first arrange the even digits and then find out the possible places and arrange the odd digits within them. Likewise, it can be for boys and girls or men and women. Let's say we have 5 men and 6 women. Altogether we have 11 persons. 11 persons can be arranged in 11 factorial ways. But the question says no 2 men have to be together. So we first arrange the women. Then we find out all the possible positions in which the men can be placed. Then arrange the men in those places to get the required answer. Let's now look at the second one here. The letters A and T are never together. So this is again similar to bit number 1. Here, these 2 letters A and T are not to be together in any word that is formed. So we first arrange the remaining letters. So leaving A and T in the given word, if A and T are left out, the remaining letters are E, D, U, C, I, O, N. So E, D, U, C, I, O, N. These are 7 letters and they can be arranged in 7 factorial ways in 7 positions. So we get 7 factorial arrangements. Now after arranging these 7 letters in 7 factorial ways, we have to now find out those positions in which the 2 letters A and T can be placed. Now we find that the positions here are in between positions and the extreme positions. So 1, 2, 3, 4, 5, 6, 7 and 8. So these are the 8 positions in which we can place the letters A and T. You take any 2 positions, we find that in between them at least one of the remaining letters will come. So that means they are never together. So out of these 8 positions, we need to select 2 and arrange the 2 letters in those 2 positions. So that's like total we have got 8 objects. We need to arrange 2 of them at a time. So that can be done in 8p2 ways. So we can say it is 7 factorial into 8p2. That's the answer for this particular question. So this is the difference between example number 4 and example 5. In example 5, when we want certain objects to be together, we join them and consider it as one unit. Do the total arrangements and then internal arrangements. And in example 5, that is when we want objects not to be together, we first arrange the remaining objects, find the possible positions and then place these objects in the given positions. Let us now take the model 4 of this topic, where we shall discuss questions related to conditions on digits. Like in model 3, we have seen various conditions that can be asked with respect to letters of a word. Here we see what are the different types of conditions that can be asked when digits have to be arranged and numbers have to be formed. Let's look at the first example. How many 5-digit numbers can be formed with the digits 2, 4, 5, 8 and 9 when the first bit here says repetition is not allowed and second bit says repetition is allowed. So here in this example we are going to see what is the difference in these 2 cases. The first case here is when the repetition of these digits is not allowed in the number. And the second bit here is when the repetition of the digits is allowed. Now let's see how to solve the questions here. Now the first bit here is quite similar to what we have done in example number 1. That is how to form a 4-digit number from the given digits. In general, when nothing is specified in the question, we should take it for granted that the repetition is not allowed. So here we have got 5 digits and we need to form 5-digit numbers. 1, 2, 3, 4 and 5-digit numbers. So 5 digits and 5 positions can be done in 5 factorial ways. Why? Because this is nothing but 5p5. 5p5 is 5 factorial. So we say that the answer here is 120. Otherwise, even if we go for the multiplication principle, we find that first position can be filled in 5 ways. 2, 4, 5, 8 or 9. Any of those 5 digits can come. Second position can be filled only in 4 ways. Third can be filled only in 3 ways. fourth can be filled in two ways, and the fifth one can be filled only in one way. Whatever digit is left out, that has to come in the fifth position. So altogether, going by the principle of multiplication, it is 5 into 4 into 3 into 2 into 1, which is again 5 factorial. So when repetition of the digits is not allowed, we take it as 5 into 4 into 3 into 2 into 1. Why? Because once a particular digit has come in the first position, it cannot come again. That is the reason we have only 4 choices. Likewise, again, once a digit comes here, it cannot come in the remaining positions. So we have only 3 choices for the third position, and so on. So that gives us the answer as 5 factorial. And in general, as I've mentioned, when nothing is given regarding repetition, we should assume that repetition is not allowed. Now a special case here is when repetition is allowed. That means how many 5-digit numbers can be formed with the digits 2, 4, 5, 8 and 9 when repetition of the digits is allowed. That means a particular digit can come any number of times in the given number. So let's see how to solve questions when the repetition of digits is allowed. Here again, since we are forming 5-digit numbers, we have got 5 positions, 1, 2, 3, 4 and 5. Now if we try to go by the principle of multiplication, we know that the first position here can be filled in 5 ways. Either 2 can come, or 4, or 5, or 8, or 9 can come. So there are 5 ways to fill the first position. That's like similar to what we have done in the first bit. Repetition is not allowed. There also first position can be filled in 5 ways. Here also the first position can be filled in 5 ways because we have 5 choices. Now coming to the second position here, the second position can again be filled in 5 ways. Why? Because repetition is allowed. So whatever digit comes here, the same digit can come again. In the previous case, we have seen that the second position can be filled in only 4 ways. Why? Because once a particular digit comes here, let's say the digit 4 has occupied the first position, then 4 cannot come in the remaining positions. That is the reason we say that second position can be filled in only 4 ways. That is either 2 or 5 or 8 or 9 and so on. So once a digit occupies a particular position, it cannot come again. So that is the reason the number of choices keep decreasing here. But in this case, since the repetition is allowed, whatever digit comes here, the same digit can come again. Let's say here 4 has occupied the first position. Again 4 can come in the second position. Likewise, it can come in the third, fourth and fifth position. Why? Because repetition is allowed. So we can say that second position can be filled in 5 ways. Again, the third position also can be filled in 5 ways. Why? Because a digit can come any number of times. So there is nothing like a particular digit is ruled out once it has occupied a particular position. Likewise, fourth position can be filled in 5 ways, and the fifth position as well can be filled in 5 ways. Now going by principle of multiplication, it is 5 into 5 into 5 into 5, which is nothing but 5 power 5. So when repetition is not allowed, the answer should be 5 factorial. And when repetition is allowed, the answer here will be 5 to the power of 5. Let's take an example and understand what can happen in this case and what cannot happen there. For example, here we can have a number called 44,444. 4 is there in the given digits. So we can form a number only using 4s. Likewise, we can have a number 55,555 or 88,888. Similarly, 99,999 or 22,222. Or it is not compulsory that all the 5 digits have to be repeated. Only 4 may repeat. For example, the number can be 22224 or it can be 22522 or 22922. Likewise, only 3 of them may repeat. We can have a number like 99294. So here we find that a particular digit has appeared thrice, remaining digits have come only once. So these are the numbers which can come in this case. These are all okay when repetition is allowed, but these things are not applicable when it comes to repetition is not allowed. Why? Because their digits should not repeat. So here we can have only unique numbers. We can have a number called 24589 in this case. This is okay. Similarly, we can have a number like 25489. That means digits all remain same. They appear only once, but they can shuffle their positions. Internally, they can be changed. Likewise, we can have a number starting with 5, 8, 9, 4, 2 and so on. So we get 120 such numbers. And here we get 5 power 5 numbers where repetition is allowed. Let's now take the second example from model 4, where again we are going to solve a question related to arrangement of digits so that different numbers can be formed. But here one of the digits is 0. So hence it becomes a special case and we need to be careful while solving such questions. Let's look at the question first. How many 4-digit numbers can be formed with the digits 0, 1, 3 and 6? So as you can see here, we have got 4 digits 0, 1, 3 and 6, and we need to form 4-digit numbers. In general, when there are 4 digits and 4-digit numbers have to be formed, we say that the answer is 4 factorial. So if we take the answer as 4 factorial, we are trying to say that the first position can be filled in 4 ways. That means either 0 can come, or 1, or 3, or 6 can come in the first position. The point here is, if first position can be filled in 4 ways, there may be some numbers where the first position is occupied by 0. And once the first position here is occupied by 0, the number becomes a 3-digit number. Why? Because this is thousands place. If this is 0, the number is not a 4-digit number. It becomes a 3-digit number. Hence, it is very clear that first position cannot be occupied by 0. So let us see how to solve this question where one of the digits is 0. We very well understand that the first position here, or the thousands place, cannot be occupied by 0. Why? Because we are trying to form a 4-digit number. Hence 0 cannot come in this place. But 1 or 3 or 6 can come. That means we have 3 choices for the first position. It can be 1 or 3 or 6. So we can say the first position here can be filled in 3 ways. Let's say 6 has occupied the first place. Now moving on to the second position, we again have 3 choices. We should not take it as 2 choices. Why? Because 0 cannot come in first position, but 0 can come in the remaining 3 positions. So we can say that the second position again can be filled in 3 ways. It can either be 0 or 1 or 3. That means any of the remaining 3 digits. So second position can also be filled in 3 ways. Let's say 1 has occupied the second position. Now moving on to the third position, we have got 2 choices. It can either be 0 or 3. So this can be filled in 2 ways. Assuming that 0 comes in this position, the last position can be filled in 1 way. Why? Because there is only 1 digit left out, 3, and it has to come there. So we don't have any choice. Last position can be filled only in 1 way. So the answer here will be 3 into 3 into 2 into 1, going by the principle of multiplication. 3 into 3 is 9. 9 into 2 is 18. So 18 is the number of 4-digit numbers that can be formed using the digits 0, 1, 3 and 6. Let's now look at the third example from module 4, which is again based on a special condition on the given digits. The question here is, how many 4-digit numbers can be formed using the digits 5, 6, 8 and 9, such that we have got 2 different conditions here. The first one says the number is greater than 8,000, and the second condition is the number is less than 6,000. So look, taking the first condition here, the question is how many 4-digit numbers can be formed using these digits 5, 6, 8 and 9, such that the number formed is greater than 8,000. So whatever numbers we form here, we should make sure that it is greater than 8,000. Now since we are going for a 4-digit number, we say that there are 4 digits, 4 positions. Now we want the number to be greater than 8,000. See, whether a number is greater than 8,000 or not is only based on its thousands place here. So here we say that the thousands place is the first position. So if we want the number to be greater than 8,000, this position cannot be occupied by 5 or 6. Why? Because once thousand place is occupied by 5, whatever be the remaining 3 digits, number will become less than 8,000. Similarly, if this position is occupied by 6, whatever be the remaining digits, it is a number which is less than 8,000. So it cannot be occupied by 5 or 6. But 8 and 9 both can come in the first position. If it is starting with 8, the remaining digits here are given in such a way that the number becomes greater than 8,000. And even when the number starts with 9, whatever be the remaining digits, it is greater than 8,000. So we can say that the first position can be occupied in 2 ways. It can either be 8 or it can be 9. Now once the first position is filled, we have got 3 more positions and remaining 3 digits. That can be done in 3 factorial ways. Why? Because condition is only with respect to thousands place. Remaining digits can be any of the given digits there. So we can say that the answer here is 2 into 3 factorial. Why? Because remaining 3 positions can be filled in 3 factorial ways. So 2 into 3 factorial is nothing but 2 into 6, which is equal to 12. So 12 numbers can be formed using the digits 5, 6, 8 and 9, where the number is greater than 8,000. Let us now look at the next condition there. The number should be less than 6,000. So this is like a similar condition, but the only point here is number has to be less than 6,000. Now again, since we are forming 4-digit numbers, we have got 4 positions. Now if we want the number to be less than 6,000, very clearly the given digits are 5, 6, 8 and 9. So if we want the number to be less than 6,000, first position here cannot be occupied by 6. Why? Because once the thousands place is 6, number becomes 6,000 or more than 6,000. We want it to be less than 6,000. So it cannot be occupied by 6. And it cannot be occupied by 8 or 9. But because when this is 8, when thousands place is 8 or it is 9, whatever be the remaining 3 digits, number is greater than 6,000. We want it to be less than 6,000. So here 6 cannot come, 8 cannot come and 9 cannot come. But 5 can come, and that's the only choice we have. So the first position can be filled only in one way. That is, the digit 5 has to come there. Now the left out digits 3 digits and 3 positions can be filled in 3 factorial ways. So we can say the final answer here is 1 into 3 factorial. That is nothing but 1 into 6, which is equal to 6. So 6 numbers can be formed where the number is less than 6,000, and 12 numbers can be formed where the number is greater than 8,000. Let us now take the fifth model from the topic of permutations and combinations, where we shall discuss about circular permutations. So far, whatever we had learned was all about linear permutations, that is arrangement of objects in a straight line or arrangement of objects in a row. But here in this model, we shall see circular permutations, that is nothing but arrangement of objects around a circle. Let's understand what is meant by circular permutation and how do we get the number of circular permutations. The number of circular permutations of n different objects taken all at a time around a circle is given as n minus 1 factorial. So if you observe, when there are n objects and we have to arrange them in a straight line, we say the number of arrangements or number of permutations are n factorial. But when we have to arrange them around a circle, then the number of permutations should be taken as n minus 1 factorial. The reason here is that for a circle, there is no definite starting point or ending point. For example, if you look at this circle, we cannot decide out of these 4 positions which is the first position or which is the last position or which is the second position. Why? Because a circle is a closed loop. We cannot decide what exactly is the first position or the last position or the starting point or the ending point. But in case of a linear arrangement, when we arrange objects or persons in a straight line, there is a definite first position and then there is a definite second, third and last positions. So due to this, when it comes to circular permutations, we need to take it as n minus 1 factorial. The reason here is, if you look at these 3 arrangements, these are 3 circular arrangements. Let's say A, B, C and D are 4 persons who have been arranged around a circular table. Now if you look at this, the first arrangement says A, B, C and D in these 4 positions. And then in the second arrangement we have D, A, B, C. And in the third arrangement we have same 4 persons but their positions are A, D, C and B. Now if you try to compare, there is no difference between arrangement number 1 and arrangement number 2. Why? Because in arrangement number 1 we see that the order is A, B, C, D. And in arrangement number 2 as well, the order remains same, that is A, B, C and D. We cannot say that here the first position was occupied by A and here the first position is occupied by D. Why? Because there is nothing called first position or second position or last position for a circle. So it's like the relative position of the persons are important. Only the relative positions of the persons have to be considered, but not the actual positions. So here if we observe, the left and right of A are B and D. Even in this permutation, the left and right of A are B and D respectively. Likewise, here if you observe, A is opposite to C. Even in this case, A is opposite to C. Or B is opposite to D. Here also B is opposite to D. Or we can say that the left and right of C are D and B. Here also the left and right of C are D and B respectively. That means there is no difference between the first arrangement and the second arrangement. So very clearly, when we go for circular permutations, only the relative positions of the persons or the relative positions of the objects have to be considered, but not the actual positions. Now if we try to compare arrangement number 1 with arrangement number 3, in arrangement number we find that the order was A, B, C, D. But in arrangement number 3 we find that the order is A, D, C, D. That means in arrangement 1, when we go for clockwise direction, the order is A, B, C, D. But here when we go for clockwise direction, the order is A, D, C, B, which is different from the first one. So hence arrangement number 1 and arrangement number 3 are different from each other, whereas arrangement 1 and 2 are same, because in both these cases clockwise order is same, A, B, C, D, A, B, C, D. So now if we try to compare all these 3 arrangements together with respect to the relative positions, we find that in all the 3 arrangements, A is between B and D. Here also A is between B and D. Here also A is between B and D. But in the first 2 arrangements, if you observe, the sequencing is same. It is DAB in the clockwise direction. Here also it is DAB in the clockwise direction. That means left and right of A are same in both the arrangements. But when we compare with the third one, the sequence is not same. In the clockwise direction it is BAD, whereas in the first 2 cases it was DAB. So that is the reason only relative positions have to be considered. So first and second are same. Arrangement 1 and arrangement 2 are same, exactly same to each other, and first and 3 are different. The first arrangement and the third arrangement are totally different from each other. The reason why we take n minus 1 factorial is because we fix one of the person's position or one of the object's position, and only the remaining are arranged in the left out positions. So that gives us the different relative positions. So that is the reason it is n minus 1 factorial. Let us now look at the next point from circular arrangement. Here the number of circular permutations of n different objects taken all at a time around a circle, where a particular arrangement in clockwise direction is considered same as a similar arrangement in anti-clockwise direction, is given as half of n minus 1 factorial. For example, let's say that we have to make a bracelet using 4 different color beads: red, yellow, blue and green. So we have got 4 different beads using which we have to make a bracelet. So that's like a circular arrangement of the 4 beads around the bracelet. Now, as given in the point, the number of circular permutations of n different objects. So here we have 4 different beads taken all at a time around a circle. So all the 4 beads are taken at a time and we have to arrange them around a circle. But keep in mind that a particular arrangement in clockwise direction is considered same as a similar arrangement in anti-clockwise direction. Then the answer should be taken as half of n minus 1 factorial. For example, let's say that we have arranged the beads in this manner: red, yellow, blue and green. So in the clockwise direction when we go, the arrangement is R, Y, B, G: red, yellow, blue and green. Now in the second arrangement here, if you observe, the arrangement is red, green, blue and yellow. But if we go in the anti-clockwise direction, it again comes out to be the same: red, yellow, blue and green. So here as well the order is red, yellow, blue and green. Now here these two arrangements are considered to be the same. Why? Because in clockwise direction it is RYBG, in anti-clockwise direction also the arrangement of beads result in RYBG. These cannot be taken as 2 different arrangements. Hence the answer is half of n minus 1 factorial. So if it is number of persons who have to be arranged around a circle, we take it as n minus 1 factorial. But when it is like beads which have to be arranged around a bracelet or which have to be arranged around a necklace, then we take it as half of n minus 1 factorial. Now the point to be understood here is, why are these two taken as same? Why are these two not considered to be different? Like in the previous case, we have understood that clockwise direction and anti-clockwise direction is considered to be the 2 different cases. But here both of them are considered as the same case. Why? Because let's say this is one arrangement: red, yellow, blue and green. So we have got a bracelet where the order is RYBG. Now the same bracelet here can be turned over or can be flipped over and we find that this is the new arrangement: red, green, blue, yellow. So the point here is, whatever is the order in clockwise direction, same can be obtained in the anti-clockwise direction just by flipping over the bracelet or by flipping over the necklace. So that is the reason whenever we do such arrangements of making a necklace or making a bracelet, or let's say we make a garland using different colored flowers, in these cases the clockwise and anti-clockwise are considered as same. These two cannot be considered as different. So hence the answer should be taken as half of n minus 1 factorial. Let's now take examples related to circular arrangements. The first example here is, in how many ways can 6 persons be seated around a circular table for dinner? So here we have got 6 persons who have to be seated around a circular table. Now we know that the number of circular permutations that can be done is given by n minus 1 factorial, and n here is nothing but 6. So we can say that the answer is 6 minus 1 factorial, that is equal to 5 factorial, which is 120. So there are 120 different ways in which 6 persons can be seated around a circular table for dinner. Remember friends, in this case there is a difference between a clockwise arrangement and an anti-clockwise arrangement, and that is the reason the answer is taken as n minus 1 factorial. But whenever a clockwise arrangement is considered to be the same as a similar arrangement in anti-clockwise direction, then it should be taken as n minus 1 factorial by 2, or half of n minus 1 factorial. The second example here is, how many different garlands can be made using 12 flowers of different colors. So we have got 12 different flowers here based on their colors, and we need to make different garlands using these flowers. So how many such garlands can be made? Now very clearly we have learned that whenever we make a garland or a necklace or a bracelet, the clockwise arrangement is considered to be the same as a similar anti-clockwise arrangement. The clockwise and anti-clockwise arrangements are not distinguished from each other, and hence the answer here should be taken as half of n minus 1 factorial. So it can be taken as half of, n is nothing but total 12 flowers here, 12 different flowers. So 12 minus 1 factorial, that is nothing but 11 factorial by 2. So that's the answer for example number 2 here. So the very simple point here is, in case of circular arrangements, the answer should be taken as n minus 1 factorial when clockwise and anti-clockwise are considered to be different from each other. And the answer should be taken as half of n minus 1 factorial when clockwise and anti-clockwise arrangements are considered to be the same. Let us now take the sixth model from this topic, where we shall discuss a couple of questions which will clearly help us understand when to go for repetitions and when not to use repetitions in a general case. The first example here is, 8 boys participated in each of 5 different competitions. In how many different ways can the winner prize be given for all the competitions? So here total there are 8 boys who have participated in each of 5 different competitions. That means there are 5 different competitions and all these 8 boys have participated in each one of them. And the question is, in how many different ways can the winner's prize be given for all the competitions? So let's say there are 5 prizes here. Prize 1 for competition 1, prize 2 for competition 2, prize 3 for competition 3, prize 4 for competition 4 and prize 5 for competition 5. So for each competition we have got a prize here. So let us now understand how can these 5 prizes be distributed among these 8 boys for these 5 competitions. Now prize 1 here is for competition 1. Let us say out of these 8 boys, any one boy is the winner of competition 1. So prize 1 can be given in 8 different ways. Why? Because any one of these 8 boys can be the winner. So prize 1 can be given in 8 ways. So there are 8 ways to distribute prize number 1. That is for competition 1. Now when we go for competition 2, that is prize 2, again it can be given in 8 different ways. Why? Because the person who has already won the prize in competition 1 can again win this prize in competition 2 as well. So we can say that even prize 2 can be given in 8 different ways. Likewise, prize 3 also can be given in 8 ways. Prize 4 in 8 different ways and prize 5 in 8 different ways. So that comes out to be 8 to the power of 5. That means there are 8 to the power of 5 different ways in which the 5 prizes for these 5 competitions can be distributed among 8 boys. So from this solution we can very clearly understand that the same boy or the same person can win in all the 5 competitions. So that is the reason we are taking 8 into 8 into 8 into 8 into 8. That means there are 8 ways of giving the prize for each of the competitions. Let's say repetition is not allowed. That means a person who has already won in competition 1 cannot win in competition 2. In that case, if the first prize can be given in 8 ways, then second prize can be given only in 7 ways. Why? Because the person who has already won in competition 1 cannot win in competition 2. Then the third prize can be given only in 6 ways, fourth prize in 5 ways and fifth prize in only 4 ways. But here, since nothing has been specified, we can assume that a person can win all the 5 competitions. And going by that, we can say that the answer here is 8 power 5. Let us now take the second example from model 6. In how many ways can the top 3 ranks be awarded for a particular exam or competition involving 12 participants? Now again, a very simple question which says, in how many ways can we give top 3 ranks or top 3 positions for a particular exam or competition which has got 12 participants or 12 competitors? Now here, if we understand, there are 3 ranks, rank number 1, rank number 2 and rank number 3. Now the first rank can be given in 12 different ways. Why? Because there are 12 different participants. So any of these 12 persons can get the first rank. So very clearly the first rank can be given in 12 ways. Now the second rank here can be allotted only in 11 different ways. Why? Because the person who has already won the first rank cannot compete for the second rank now. He's already got the first rank, so he cannot come in the race for second rank. So second rank is available only for any of the remaining 11 persons. So we can say that second rank can be given here in 11 ways. And likewise, the third rank can be given to any one of the remaining 10 persons. So the first rank can be given to any one of the 12 persons, second rank can be given to any one of the remaining 11 persons, and the third rank can be given to any one of the left out 10 persons. Now altogether these 3 ranks can be given in 12 into 11 into 10 ways. 12 into 11 is 132, into 10 is 1320. So we can say there are 1320 different ways in which the top 3 awards or the top 3 ranks can be given in a competition which has got 12 participants. So as you can see here, because these are the 3 prizes or 3 ranks within a same competition, we cannot have repetition. But in the previous example, there were 5 different competitions and we are giving prize for each of the competitions. So the same person can win in all the 5 competitions, and hence repetition was considered there. But here we cannot consider repetition. Why? Because a person can get either a first rank or a second rank or a third rank, but he cannot get any 2 of them or all 3 of them. He should get only any 1 of them. So this is how, based on the question, we can decide whether repetition has to be considered or should not be considered. So try to understand the question properly and then go for the solution to get the right answer. Let us now take the 7th model from this topic of permutations and combinations, where we shall discuss basic questions related to combinations. We all know that combinations is nothing but selection or grouping of some or all the given objects. And the number of combinations of n objects taken r at a time is given as NCR, which is equal to n factorial by n minus r factorial into r factorial. So let us see some applications of this formula, that is NCR. The first example here is, in how many different ways can a committee of 8 persons be formed out of 5 men and 3 women? So here we need to form a committee of 8 persons out of 5 men and 3 women. So there are 3 women and 5 men, and we need to form a committee of 8 persons. In general, forming a committee of persons or a group of persons is considered to be combinations. Why? Because when we form a committee or a group of persons, only selection is required, arrangement is not required. Or I can say the order in which the persons are selected doesn't make a difference. Now, since the order is not important, we can say that this is combinations or selections, which can be given as NCR, that is n factorial by n minus r factorial into r factorial. Now here we find that there are 5 men and 3 women. That means total there are 8 persons, and we need to form a committee of 8 persons. That means very clearly 5 men plus 3 women will be equal to total 8 persons. And now we need to form a committee of 8 persons out of all these 8 persons. So we can say that the answer here is 8C8. NCR should be taken as n factorial by n minus r factorial into r factorial. So we can say that the answer here will be 8C8, which is equal to 8 factorial by 8 minus 8 factorial into 8 factorial. Now this can be taken as 8 factorial by 8 minus 8 factorial is 0 factorial multiplied with 8 factorial. So this 8 factorial and 8 factorial gets cancelled, and we are left out with 1 as the answer. Why? Because 0 factorial is equal to 1. So we can say that 8C8 is equal to 1. Now one important point that we can understand here is, because there are total 8 persons and we need to form a committee of 8 persons, we don't have any choice. All the 8 persons have to be selected, and that can be done only in one way, that is all of them have to be selected. So that is the reason 8C8 is equal to 1. So we can say that whenever r is equal to n, NCR will be equal to 1. So just remember that if r is equal to n, then NCR will be equal to 1. For example, 6C6 will be equal to 1, or 12C12 is equal to 1, or 25C25 will be equal to 1. Why? Because in all these cases we find that we are trying to select all the given persons in the committee. So hence we don't have any choice, and we can do it only in one possible way, that is to select all of them. So that is the reason whenever r is equal to 1, then NCR should be equal to 1. Let us now take the second example from model 7, where we shall take another basic question from combinations. The question here is, in how many ways can a cricket team of 11 players be chosen out of total 14 players? So that's a very simple and straightforward question, where we have to form a cricket team of 11 players out of total 14 players. Now we know that because this is only a selection part, where we are forming a team or forming a committee, it should be taken as a combination. And the number of combinations of n persons or n objects taken r at a time is given as NCR, which is equal to n factorial by n minus r factorial into r factorial. So this is what is to be used for solving questions from combinations, that is forming a committee or forming a team. Now from the given question we can see that the total number of players that we have is 14. So n is nothing but 14, and we are trying to form a cricket team of 11 players. So r is equal to 11. So we can say that the answer here should be 14 C11, which will be equal to 14 factorial divided by n minus r, 14 minus 11 factorial into r factorial, 11 factorial. So this can be taken as 14 factorial by 14 minus 11 factorial is 3 factorial into 11 factorial. Now if you try to expand 14 factorial, that comes out to be 14 into 13 into 12 into 11 factorial divided by 3 factorial is equal to 6 into this 11 factorial as it is. Now 11 factorial and 11 factorial gets cancelled. So finally we are left out with 14 into 13 into 12 by 6. Now 6 here gets cancelled 2 times. So the final answer is 14 into 13 into 2, which comes out to be 364. So we can say there are 364 different ways in which a cricket team of 11 players be formed out of 14 players. So the answer for this question is 364. Now before we take up the next model, one important point that I would like to mention here is NCR is always equal to NC of n minus r. NCR can always be taken as NC n minus r. For example, here 14C11. 14C11 can be taken as 14C 14 minus 11. 14 minus 11 is equal to 3. We anyway know that 14C11 is equal to 364. Let us find out what is 14C3. Even this should come out to be 364. Now 14C3 can be taken as 14 factorial by 14 minus 3. 14 minus 3 is 11 factorial into r factorial here is 3 factorial. So if you try to compare 14C3 is 14 factorial by 11 factorial into 3 factorial. And 14C11 we know is 14 factorial by 3 factorial into 11 factorial. So very clearly NCR is equal to NC n minus r. So this point may be helpful in doing certain calculations very fast. Let us now take the 8th model from this topic of permutations and combinations, where we shall discuss questions related to combinations but with a condition given in the question. Earlier in model 7 we have taken basic questions from combinations, but now we shall take up questions where selection of a team or a committee has to be done along with certain conditions to be followed. Let's look at the first example. Out of 10 men there are 4 doctors, 3 teachers and 3 lawyers. And out of 8 women there are 3 doctors, 3 dancers and 2 lawyers. In how many ways can a committee of 5 persons be formed such that there are 3 doctors and 2 lawyers? Now here as you can see we have got 2 groups, group of 10 men and another group of 8 women. Out of 10 men there are 4 doctors, 3 teachers and 3 lawyers, and out of 8 women there are 3 doctors, 3 dancers and 2 lawyers. So altogether 4 plus 3 plus 3 is 10 men and 3 plus 3 plus 2 is 8 women. So we have a total of 18 persons in the group, and we are supposed to form a committee of 5 persons such that there are 3 doctors and 2 lawyers in this committee. Now we know that forming a committee or forming a team comes under combination, and we need to go for NCR, that is n factorial by n minus r factorial into r factorial, where n is the total number of persons and r is the number of persons which have to be selected or which have to be chosen. Now without any condition we can say that there are 18 persons here. So when there is no condition we can say that the answer, that is in how many ways can a committee of 5 persons be formed out of 18 persons, can be taken as 18C5. Now by simplifying this we get the required answer. But here we have a condition. The condition says there should be 3 doctors and 2 lawyers. That means out of 5 persons which have been selected in the committee, there have to be 3 doctors and 2 lawyers. Now altogether if we try to observe, we have 4 male doctors and 3 female doctors. So total we have got 7 doctors. And we have got 3 male lawyers and 2 female lawyers. That means total we have got 5 lawyers. So out of these 18 persons we can say 4 plus 3. There are 7 doctors and 3 plus 2. There are total 5 lawyers. Now we need to form a committee of 5 persons such that there are 3 doctors and 2 lawyers. Now if we have to select 3 doctors, the total choice that we have here is 7. Out of these 7 doctors, it can be a male doctor or can be a female doctor. Why? Because nothing regarding the gender has been given in the question. So out of total 7 doctors we need to choose 3. We know that we can select 3 doctors out of 7 in 7C3 ways. And out of these total 5 lawyers, again the gender has not been specified, so it can be either a male lawyer or a female lawyer. So we have got total 5 lawyers and we need to select 2 of them. And we know that out of 5 we can select 2 lawyers in 5C 2 ways. Now going by the principle of multiplication, one action can be done in 7C 3 ways. The other action can be done in 5C 2 ways. And since we are forming a committee of 5 persons here, both the actions have to be done together. So we can say the final answer is 7C3 into 5C2. So the committee which has got 3 doctors and 2 lawyers will be formed in 7C3 into 5C2 ways. So by simplifying that, we get the answer for this question. Let us now take the second example from model 8. The question here is, out of 10 women there are 4 doctors, 3 teachers and 3 lawyers. And 8 women there are 3 doctors, 3 dancers and 2 lawyers. So in how many ways can a committee of 5 persons be formed such that there are 2 teachers and 1 doctor in the committee? So this time the question says, out of the 5 members of the committee there should be 2 teachers and 1 doctor. Now understand friends, here it is given that there should be 2 teachers and 1 doctor. That means the remaining 2 persons can be of any other profession, but there must be 2 teachers and 1 doctor. And also, whenever such a condition is given, understand that there can be only 2 teachers. We cannot take more than 2 teachers. And likewise, there can be only 1 doctor. We cannot take more than 1 doctor. So there has to be exactly 2 teachers and exactly 1 doctor in the committee, and remaining 2 persons can be of any other profession. Now as given in the question, we know that there are total 10 men, out of which 4 are doctors, 3 are teachers and 3 are lawyers. And there are 8 women. Out of these 8 women, there are 3 doctors, there are 3 dancers, let us take dancers as dancers, and 2 lawyers. There are 2 lawyers. Now we need to form a committee of 5 persons in such a way that there are 2 teachers and 1 doctor. Now when we want 2 teachers, we see that there are total 3 teachers in this group. There are only male teachers, there is no female teacher here. So out of these 3 teachers, we need to select 2. That can be done in 3C 2 ways. Then we need 1 doctor. There are total 7 doctors, 4 male doctors and 3 female doctors. Out of 4 plus 3, 7 doctors, we need to select 1 of them. Remember again, here nothing about the gender has been specified. So it can be either a male doctor or a female doctor. That is the reason we consider total 7 doctors. Out of 7, we need to take 1. That can be done in 7C 1 ways. So altogether so far we have got 2 persons as teachers and 1 person as doctor. Now we know that the committee should have total 5 persons. Already 2 plus 1, 3 persons have been selected. Now we need 2 more persons. Now to select those 2 persons, we should not consider the doctors here. Why? Because as given in the question, there should be only 1 doctor and that has been taken. So these doctors cannot be considered now. And also the 3 teachers must not be considered. Out of the remaining professions, that means lawyers or dancers, we can select the remaining 2 persons here. Now total we have got 3 plus 3 plus 2, 8 persons, 3 dancers and total 5 lawyers. Out of 5 and 3, 8 persons, we need to select 2 more persons. So that can be done as 8C 2 ways. So we find that total we have got 5 persons now. 2 teachers out of total 3 teachers, 1 doctor out of total 7 doctors, and remaining 2 persons out of remaining 8 persons there. Now we know that 3C2 is nothing but 3 factorial divided by 3 minus 2, 1 factorial into 2 factorial, into 7C1 is equivalent to 7 factorial by 7 minus 1, 6 factorial into 1 factorial, into 8C2 is 8 factorial divided by 8 minus 2, 6 factorial into 2 factorial. Now this can be simplified to get the required answer. 7 factorial by 6 factorial will be equal to 7. Why? Because 7 factorial is nothing but 7 into 6 factorial. So 6 factorial gets cancelled. We are left out with 7. Likewise, 8 divided by 6 factorial can be taken as 8 into 7. Why? Because 8 factorial is 8 into 7 into 6 factorial. So that 6 factorial gets cancelled. 2 factorial is equal to 2. That is very clear. Again here 1 factorial is 1, 1 factorial is 1. This 2 factorial as well is 2. And 3 factorial is equal to 6. So we say that finally we have got 3 factorial, which is 6 into 7 into 8 into 7 divided by 1 factorial is 1 into 2 factorial is 2 into, here we have 1 factorial and here we have 2 factorial. So that can be taken as 2 only. So 2 into 2 is 4, which goes 2 times here. So the final answer will be 6 into 7 into 2 into 7. 6 into 7 is 42. 42 into 2 is 84. 84 into 7 can be taken as 588. So we can say there are 588 possible committees which can be formed such that there are 2 teachers and 1 doctor. So this is how we can simplify these type of calculations and get the required answer. But remember, before you do the simplification, just throw a glance at the options. Why? Because in some cases, options are given directly in terms of factorials. So there we need not simplify. Or sometimes options are given in terms of NCR. So there again, simplification is not required. Only when the options are given in actual number of ways, we need to do the simplification and get the required answer. Let us now take the third example from model 8, where again we are going to take a new condition. Again the similar data. Out of 10 men, there are 4 doctors, 3 teachers, 3 lawyers. And out of 8 women, there are 3 doctors, 3 dancers and 2 lawyers. So different genders and different professions. In how many ways can a committee of 5 persons be formed such that there are 2 female doctors and 2 male lawyers? Now as you can see, this is a profession and gender based condition. We need to have 2 female doctors and 2 male lawyers. So very specifically, the gender as well as the profession has been specified. Now again, the working here remains same. First of all, we need to select those persons as given in the condition. We need 2 female doctors. Total we have 3 female doctors in the given question. So we can say 2 female doctors can be selected in 3C 2 ways. There are 3 women doctors, 3 female doctors. We need 2 of them. So that can be done in 3C 2 ways. So out of 3, 2 have been selected. And we need 2 male lawyers. Altogether we have got 3 male lawyers. But because there are 3 lawyers under 10 men. So out of these 3, we need to have 2 of them. So again that can be done in 3C 2 ways. Now so far we have selected 2 plus 2, 4 persons in the committee. But the question says we need to form a committee of 5 persons. That means 1 more person is required. And this 1 person can be any one of the remaining persons. Remember, so far we have dealt with 3 doctors, 3 female doctors and 3 male lawyers. Now apart from these persons, we can have the left out person from any one of the remaining groups. That means total we see that there are 4 doctors or 4 male doctors, 3 teachers. So that is 7, and 3 dancers, 10, and 2 lawyers, 2 female lawyers, that is 12. So out of the remaining 12 persons, we have to select 1 person. That can be done in 12C 1 ways. And going by the principle of multiplication, we can say that altogether the number of ways will be 3C2 into 3C2 into 12C1. And this can be simplified as 3C2 is nothing but 3C1, which is equal to 3, into 3C2 again will be equal to 3, into 12C1 is 12. So 3 into 3, 9, 9 into 12 is 108. So there are 108 ways in which a committee of 5 persons can be chosen such that there are 2 female doctors and 2 male lawyers included in the committee. Now the important point that we need to understand here is when the question says there have to be 2 female doctors and 2 male lawyers, it doesn't mean that we cannot have male doctors or female lawyers in the committee. If there are extra persons required, then those extra persons can be male doctors or they can be female lawyers as well. So that is the reason after selecting 2 female doctors out of 3 and 2 male lawyers out of 3, we are considering all the remaining persons. That means we are taking 4 male doctors and 2 female lawyers as well into consideration. So altogether we see that 4 plus 3, 7 plus 3, 10 plus 2, 12 persons are there. Out of 12 we need 1 more. Let us now take the 4th example from model 8. Again, with respect to the same number of persons, the condition here says there should be at least 3 doctors in the committee. In how many ways can a committee of 5 persons be formed such that there are at least 3 doctors in the committee formed? Now we know that there are 10 men, 8 women, and these are the different professions that we have. 4 doctors, 3 teachers, 3 lawyers, 3 doctors, 3 dancers and 2 lawyers. Now we need to form a committee of 5 persons such that at least 3 are doctors. And gender has not been specified. So it can be a male doctor or can be a female doctor. Now the word at least here means that minimum there has to be 3 doctors. So there can be 3 doctors and 2 persons of other professions, or we can have 4 doctors and 1 person of other profession, or we can have all the 5 as doctors. So here there are 3 possible cases. We can say when we have to form a committee of 5 persons, in these 5 persons there can be 3 doctors and 2 persons can be of other professions, 2 persons of other professions. Or the other possible way here is there can be 4 doctors and 1 person of other profession. Or finally we can say all the 5 can be doctors. So these are the 3 possible cases. 3 doctors, 2 of other professions, 4 doctors, 1 person of other profession, or all the 5 are doctors. Now simply by doing the combinations for each one of them, we can get the required answer. Remember friends, whenever we have 3 different cases, we always need to take it as plus in between them. That is, whenever the word or is used, in case of permutations and combinations, we should take it as plus. So number of combinations for this case, plus number of combinations plus for this case plus number of combinations for the last case. Now if you try to observe, altogether we have got 4 plus 3, 7 doctors. And apart from doctors, there are left out 11 persons of other professions. 3 plus 3, 6 plus 3, 9 plus 2, 11. So there are 11 persons of other professions. So let's see in how many ways can we go for the first one. Now 3 doctors out of 7 can be selected in 7C 3 ways into 2 of other professions. Out of 11 persons of other professions, we need to select 2. That can be done in 11C 2 ways. Remember, this plus here doesn't mean that we have to take plus. Plus means what? We are doing both of them together. And going by the principle of multiplication, when 2 actions are done together, we have to take into in between them. So 7C 3 ways into 11C 2 ways. But here we should take it as plus, or always means plus. Now the second one here is 4 doctors and 1 person of other profession. So out of 7 doctors, 4 doctors can be selected in 7C 4 ways. And the other person can be selected out of remaining 11 persons. So that can be done in 11C 1 ways. And finally, the third case, or again is plus. 5 doctors. All the 5 can be doctors and we need not have any other person of other profession there. So all 5 doctors out of 7 can be selected in 7C 5 ways. So that's the final answer. 7C 3 into 11C 2 plus 7C 4 into 11C 1 plus 7C 5. So this is how whenever the word at least is used, it can be any profession, can be doctors or can be teachers or can be any other profession there. At least is minimum those many persons. So it can be minimum 3 and go up to maximum 5 persons, right? Because the committee is there for 5 persons. Similarly, to make it even more complicated, we can say that in how many ways can a committee of 5 persons be formed such that there are at least 3 doctors in the committee and there is no lawyer. At least 3 doctors and there should not be any lawyer. Now in this case, the first half of the question remains same. That is, there must be at least 3 doctors, but there should not be any lawyer. So what we do here is, because the at least 3 doctors are required, it can be 3 doctors, 2 persons of other professions but not lawyers, or 4 doctors and 1 person of other profession but not lawyers, or all the 5 can be doctors. So while doing this, what we need to do is, for the second half, we need not consider these lawyers here. So we can say that out of 7 doctors, either 3 doctors or 4 doctors or 5 doctors are required, or remaining we have 3 teachers and 3 dancers. That means remaining are 6 persons. Out of those 6 persons, we can have 2 persons or 1 person or no person in the third case. So that's how you go for it. When there are at least 3 doctors and no lawyers. Simply what we do is, out of this 11, we need to remove the 5 lawyers. So 11 minus 5 will be equal to 6 persons of other professions there. And then simply we can take it as 7C3 into 6C2 plus 7C4 into 6C1 plus 7C5. So that's how, based on the condition, we just need to decide which of the persons have to be considered and which persons should not be considered in the selection. And then accordingly, by doing the number of selections, we can get the required answer. Let us now take the fifth example from model 8, where again we are going to discuss a new condition with respect to combinations. Now for the same data, that is out of 10 men and 8 women where different professions are given, we need to form a committee of 5 persons such that there is no doctor and no dancer in the committee. So the committee should have 5 persons, but there should not be any doctor or any dancer in the committee. So this is again a very simple and straightforward question, and to solve this, what we need to do is, while doing the number of selections, we simply have to skip all the doctors and the dancers. Why? Because doctors and dancers should not be considered in the committee or should not be selected in the committee. Now here we have 4 male doctors, 3 female doctors, they can be eliminated, and we have got 3 dancers only under women. So even these 3 dancers have to be eliminated. Why? Because doctors and dancers are not supposed to be a part of the committee. Now the remaining persons here are 3 teachers, 3 lawyers and 2 lawyers here. So 3 plus 3, 6 plus 2, 8. Out of these remaining 8 persons, we can select any 5 of them. Why? Because with that we satisfy the condition. We are not considering doctors and dancers. So we can simply say that the answer is 3 plus 3 plus 2. That is, out of 8, we need to select 5. 8C5. And 8C5 can be taken as 8 factorial by 8 minus 5. 3 factorial into 5 factorial. This can be further simplified as 8 into 7 into 6 into 5 factorial divided by 3 factorial is 6 into 5 factorial. So 5 factorial and 5 factorial gets cancelled. 6 and 6 gets cancelled. 8 into 7 will give 56. So there are 56 ways in which such a committee can be formed of 5 persons where there are no doctors and no dancers. So whenever a particular type of object or a particular type of person is not required, we simply have to leave those persons while doing the selections. So this is how the various type of conditions can be given for questions related to combinations. And remember friends, as I've mentioned earlier, object need not be a person always. For example, here we have persons of different professions. Likewise, we can have different colored balls. For example, 5 yellow balls, 3 green balls, 2 blue balls, and so on. And we need to select a number of balls out of them where different conditions are given, like we have discussed in these 5 examples. So whatever be the type of object, for solving questions related to combinations based on different conditions, we simply need to go as per the given condition and get the required answer. Let us now take the 9th model from this topic of permutations and combinations, where again we shall discuss questions related to conditional combinations. That is, we have to form a committee or a team following various conditions. Look at the first example here. In how many ways can a cricket team of 11 players be chosen out of 8 batsmen and 6 bowlers, such that the first bit here is there are 7 batsmen and the second one says there are 5 bowlers. So here we need to form a cricket team of 11 players out of 8 batsmen and 6 bowlers. So altogether we have a choice of 14 players, 8 plus 6, 14. But the condition says there must be 7 batsmen in the team. And the second condition here is there are 5 bowlers in the team. Now, going by the condition here, if we want 7 batsmen, the total choice that we have is of 8 batsmen. So out of 8, we need to select 7. So that can be done in 8C 7 ways. And after selecting 7 batsmen, it is obvious that the remaining 4 players have to be bowlers. Why? Because total there are 11 players in the team. Already 7 have been selected. Remaining 4 have to be bowlers. Total we have got 6 bowlers here. So out of 6 we need to select 4. So 8C7 into 6C4 is the answer for the first bit. Similarly, the second bit here is there are 5 bowlers. So when we have 5 bowlers in a team of 11 players, it is obvious that remaining 6 have to be batsmen. So 5 bowlers out of 6 can be done in 6C 5 ways, and then remaining 6 players have to be batsmen. Total we have got 8 batsmen. So that can be taken as 8C6. So these are the number of ways in which a team of 11 players can be selected where there are 5 bowlers. Let us now take the second example from model 9. In how many ways can a cricket team of 11 players be chosen out of 8 batsmen and 6 bowlers, such that the first bit here is the majority is of batsmen, and second bit here is such that there are not more than 5 bowlers in the team. Let us first look at the first condition here. The question becomes, in how many ways can a cricket team of 11 players be chosen out of 8 batsmen and 6 bowlers, such that the majority is of batsmen. Now we know that here we are making a team of 11 players. Out of these 11 players, majority have to be batsmen. That means the minimum majority that we can get out of a team of 11 would be 6. That means if there are 6 batsmen and 5 bowlers, we find that more number of batsmen are there in the team. Likewise, there can be more than 6 batsmen as well. For example, if there are 7 batsmen and 4 bowlers, still the majority is of batsmen. 8 batsmen, 3 bowlers, again majority is of batsmen. So likewise, we need to consider all those cases where the majority is of batsmen. Now if we try to understand, there can be 6 batsmen and 5 bowlers, or there can be 7 batsmen and 4 bowlers, or there can be 8 batsmen and remaining 3 are bowlers. Remember, we cannot go for more than 8 batsmen here. Why? Because total what we have here is only 8 batsmen. So simply by finding out the number of ways of choosing these type of teams and adding all of them. Why? Because as we have discussed earlier, or means plus. These are different cases. So we need to add the number of ways of doing each one of them. So by adding all of these, we get the required answer. Now 6 batsmen and 5 bowlers can be done in 8C6 into 6C5. Why? Because there are total 8 batsmen, we need to select 6, and total 6 bowlers, we need to select 5. So 8C6 into 6C5 plus 7 batsmen out of 8 can be done in 8C7 into 4 bowlers out of 6, that is 6C4. And finally 8 batsmen or 3 bowlers. 8 batsmen can be selected out of 8 in 8C8 ways into 3 bowlers out of 6 can be done in 6C3 ways. And as I've mentioned, we cannot go for more than 8 batsmen. Why? Because total what we have here is only 8 batsmen. So we can say that this is the answer for the first condition, that is the majority is of batsmen. Let us now look at the second bit here. That is, there are not more than 5 bowlers. So we need to form a cricket team of 11 players out of 8 batsmen and 6 bowlers, such that there are not more than 5 bowlers. Not more than 5 bowlers. So there can be 5 bowlers or less than 5 bowlers, but there should not be more than 5 bowlers. So we can say that here the condition says maximum there have to be 5 bowlers in the team. Minimum can be 0, but maximum has to be 5 bowlers. We cannot have more than 5 bowlers. So going by this maximum bowlers condition, we can say that there can be 5 bowlers and remaining 6 are batsmen, or we can have less than 5 as well. There can be 4 bowlers and remaining 7 are batsmen, or there can be 3 bowlers, remaining 8 are batsmen, and likewise we can go for 2 bowlers as well. Why? Because maximum it says there must be 5 bowlers, minimum can be 0. So we can also have 2 bowlers, but when there are 2 bowlers there should be 9 batsmen. Why? Because team is to be of 11 players. So 2 bowlers means there should be 9 batsmen in the team, and total what we have here is only 8 batsmen. So that is the reason we need to stop at this point itself. So now by selecting these type of players and adding all of them, we get the required answer. So 5 bowlers out of 6 can be done in 6C5 into 6 batsmen out of 8, 8C6, or is plus 4 bowlers can be taken in 6C4 ways into 7 batsmen, 8C7, or again is plus 3 bowlers can be done in 6C3 into 8 batsmen out of 8 can be done in 8C8 ways. So this is the answer for the given question. Now one other way of solving the question here would be, the question says there should be maximum 5 bowlers. Minimum can be any number of bowlers, but maximum has to be 5. We find that total there are 6 bowlers available. So instead of solving each one of them separately and then adding all of them, what we can do is, from the total number of teams that can be formed, if we subtract those teams where there are more than 5 bowlers, we get the required answer. Why? Because question says maximum 5 bowlers. So maximum can be 5. We should not have more than 5. For example, the total number of teams that can be formed here is 8 plus 6, 14 players. We need 11 players. So total is nothing but 14C11. These are the total number of teams that can be formed, or these are the number of ways in which a team of 11 players can be formed out of 8 batsmen and 6 bowlers. Now out of this total number of teams that can be formed, if we subtract those teams where there are more than 5 bowlers, we get the required answer. Why? Because maximum is 5 bowlers here. So if we subtract those cases where we have more than 5 bowlers, we get the required answer. Now here altogether we have got 6 bowlers. So more than 5 bowlers is only one case, that is 6 bowlers. So from 14C11 we subtract that number of cases where we have 6 bowlers in the team. So 6 bowlers means it is 6C6 ways, and remaining have to be batsmen. Already 6 bowlers have been selected, so remaining 5 have to be batsmen. That can be done in 8C5 ways. So this is the other way of solving the question. Let us now look at the next example from model 9. In how many ways can a cricket team of 11 players be chosen out of 8 batsmen and 6 bowlers, such that 2 particular batsmen are always included and 1 particular bowler is always excluded? Now this is a completely different question, which says 2 of the batsmen out of total 8 are always there in the team, and 1 of the bowlers out of the 6 bowlers is never included in the team. Let's see how to solve these type of questions. Now we know that there are total 8 batsmen available and 6 bowlers available. So 8 batsmen and 6 bowlers. Out of these 14 players, we need to form a team of 11 players. But as the question says, 2 particular batsmen are always included. That means out of these 8 batsmen, there are 2 such batsmen who are always included in the team. That means we are now left out with only 6 more batsmen. Our choice is only 6 more batsmen. Likewise, out of 6 bowler, 1 particular bowler is always excluded. That means that particular bowler should never be selected. So again, out of 6 bowler, if 1 is gone, our choice is only 5 more bowlers. That means now we have effectively 6 batsmen and 5 bowlers, and we need to form a team of 11 players. But remember, 2 of the batsmen are already there in the team of 11. They are always included. That means now we need to select only 9 more players. Why? Because already 2 of the batsmen are there in our team. So instead of 11, we now need only 9 players. And 1 bowler is anyway excluded, so we need not worry about that. So 2 batsmen are already there and 9 more players are required. Those 9 players have to be chosen only from these 6 batsmen and 5 bowlers. 6 plus 5 total, we have 11 players. So out of these 11 players, we now need to select 9 players. That can be done. See, this is total 11 players. and we now need to form a team of only 9 players. So that can be done in 11C 9 ways. 11C 9 is nothing but 11 factorial divided by 11 minus 9, 2 factorial into 9 factorial. So this will be equal to 11 into 10 divided by 2. Why? Because 9 factorial gets cancelled and 2 factorial is 2. So this goes 5 times and we can say the answer is 55. That means there are 55 ways in which a cricket team of 11 players can be selected given this condition. That is, 2 batsmen are always there and 1 particular bowler is never there. Let us now take the 10th model from this topic of permutations and combinations, where we shall discuss some typical questions based on combinations. The first example here is, in how many ways can a person choose one or more out of 5 different subject books? So as you can see, the word choose clearly indicates that this is a combination case. Why? Because choose is nothing but selection, and selection is combination. So here we need to use the concept of combinations, that is NCR, in finding out the answer. Now the question says, in how many ways can a person choose one or more out of 5 different subject books? So there are 5 different books here. Let us take them as B1, B2, B3, B4 and B5. So these are the 5 different books that we have. And in how many ways can we choose one or more out of these 5 different books? So one or more means it can be 1 book or 2 books or 3 books or 4 books or 5 books. So there are 5 different cases here. Now going by the first one, in how many ways can a person choose 1 book? There are 5 books, person has to select 1. It can be done in 5C 1 ways. Or he can select 2 books. Or means plus, so we need to take plus here, and 2 books can be selected in 5C 2 ways. Or he can select 3 books, so plus 5C 3 ways. Or he can select 4 books, so plus 5C 4 ways. Or he can select all the 5 books, so plus 5C 5. So this is the answer for the question here. The question says, in how many ways can a person choose one or more? One or more means it can be 1, 2, 3, 4 or 5. Why? Because maximum there are 5 books here. So 1 book can be selected in 5C1, 2 books in 5C2, 3 books in 5C3, 4 books in 5C4 and 5 books in 5C5 ways. So by adding all these, we get the required answer. Now 5C1 is equal to 5, 5C2 is 10, 5C3 will again be equal to 10, 5C4 is nothing but 5C1, which is 5, and 5C5 we know is equal to 1. Why? Because NCR is equal to 1 when R is equal to N. So this is equal to 1. So totally we get 5 plus 10 15 plus 10 25 plus 5 30 plus 1 31 ways. That means there are 31 ways in which a student can select one or more out of 5 different subject books. Apart from this way of solving the question, the other method in which we can get the answer is as follows. Now if you try to observe, a person has to choose one or more out of 5 different subject books. Let us first try to understand what can a student do with each of these books. Now as you can see here, there are 2 possibilities. He can either take the book or he can leave the book. That means he can either select the book or he can leave the book. Let's say when he approaches book number 1, there are 2 things which can be done. Either select the book or reject the book. So there are 2 things which can be done with book number 1. Likewise, book number 2, either he can take it or he can leave it. So there are 2 choices. Book number 3, take or leave, again 2 choices. Likewise for book 4 and book 5, there are 2 choices each. That means in every book here, either he can select it or reject it. That means either he can take it or leave it. Now altogether you find that there are total 2 into 2 into 2 into 2 into 2 ways. That is nothing but 2 power 5 ways. That is equal to 32 ways. That means there are total 32 ways in which books can be selected out of 5 different subject books. But remember friends, out of these 32 ways, there will be one way in which all the books get rejected. For example, book number 1 is not selected, book 2 is not selected, 3, 4, 5 are also not selected. That means out of these total 32 ways, there will be one particular way in which all the books are rejected. And in the remaining 31 ways, at least one gets selected. We know that one or more is nothing but at least one. So what we can do here is, total number of ways that can be done with these 5 books is 32 ways. Out of these 32 ways, if we subtract the one where all the books get rejected, we get the required answer. So we can say that the answer here will be 32 minus 1, that is equal to 31 ways. That's what we have got here. Either you take it as 5C1 plus 5C2 plus 5C3 plus 5C4 plus 5C5, or it can be directly taken as 2 power 5 minus 1. 2 power 5 because there are 5 different subject books, and with each book 2 actions can be done, either take it or leave it. But when we take 2 power 5, in this 2 power 5 ways, one way says all the books get rejected. So we need to subtract that. Why? Because question says one or more, at least one book has to be there. So that is the reason we subtract 1. That is the way in which no book gets selected. And we get the answer as 31. Let us now take the second example from model 10. The question says in a party there are 15 persons and every person shakes hand with every other person. So what will be the total number of handshakes? So here we find that there are total 15 persons and each of these 15 persons shakes hand with every other person present. So what will be the total number of handshakes in the party here? Now if you really look at it, this is again a case of combination. Why? Because for one handshake we need to select two persons. So indirectly the question which says what will be the total number of handshakes can be understood as what are the number of ways in which two persons can be selected out of 15 persons. Why? Because one selection of two persons will give us one handshake. So instead of finding out the total number of handshakes, we can consider it as the number of ways in which two persons can be selected out of 15 persons, and every such selection will give us one handshake. So we can say that the answer here is nothing but 15C2. 15C2 is 15 factorial divided by 15 minus 2. 13 factorial into 2 factorial. So this comes out to be 15 into 14 divided by 2. Why? Because 13 factorial and 13 factorial gets cancelled and 2 factorial is 2 here. So 2 gets cancelled 7 times here. 15 into 7, that is equal to 105. So we can say that there will be total 105 handshakes in this party. So simply we need to consider those many ways in which two persons can be selected out of 15 persons. Now like this example, a similar question can be asked in terms of the number of matches that will be played between the given number of teams. For example, let's say that 8 teams are participating in a world championship where every team plays a match with every other team. So how many matches will be played? Now here again if you see, the question is about selecting 2 teams out of the given 8 teams. Why? Because one match will be played in between 2 teams. So instead of finding out the number of matches, we can simply say that this is a case where we have to find out in how many ways can 2 teams be selected out of 8 teams. And every such selection of 2 teams out of 8 teams will result in one match. So the simple answer there can be taken as 8C2. There are total 8 teams. How many matches will be played? Where every team plays a match with every other team. So we can say that the answer is 8C2. And 8C2 can be taken as 8 into 7 by 2. This comes out to be 4 into 7. That is nothing but 28. So we can say there will be total 28 league matches in this World Championship. So these are some of the cases which are indirectly based on combinations. The number of handshakes in a party where there are some number of persons. So that is nothing but selection of 2 persons out of the given number of persons, where every selection results in a handshake. And number of matches that will be played for the given number of teams. Now for one match to be played, we need to select 2 teams. So that is again selection of 2 teams out of the given number of teams. So we simply have to decide whether the given question is based on permutations or combinations and then apply the proper formula, that is NPR or NCR, to get the required answer. Let us now take another interesting example from this model 10. The question says how many parallelograms can be formed by a set of 5 parallel lines intersecting another set of 8 parallel lines. So here we need to find out the number of parallelograms. And the question says there are 5 parallel lines intersecting another set of 8 parallel lines. So if you try to understand, there are 5 parallel lines. Let's say the 5 parallel lines are as shown, right? They are extending up to infinity. These are not line segments but lines. So they go up to infinity. These 5 parallel lines here are intersecting another set of 8 parallel lines. So they are intersecting a set of 8 parallel lines. Let's assume the remaining 8 parallel lines are as shown. 1, 2, 3, 4, 5, 6, 7 and 8. And the question says how many parallelograms can be formed with this set of 5 parallel lines intersecting another set of 8 parallel lines. Now we know that a parallelogram is a quadrilateral where the opposite sides are parallel to each other. For example, these 2 sides are parallel to each other, and again the remaining 2 sides are parallel to each other. The opposite sides are parallel to each other. So any quadrilateral that can be formed by 2 parallel lines intersecting another 2 parallel lines will result in a parallelogram. Now here we see that there are 5 parallel lines intersecting another set of 8 parallel lines. Now here number of parallelograms can be seen. This is a parallelogram, then again this is a parallelogram, this itself complete is a parallelogram, This complete figure again is a parallelogram. So we need to find out all those parallelograms that can be formed with these lines there. Now as we know that to form a parallelogram we need to have two parallel lines intersecting another two parallel lines. Now here we have 5 lines in one way and then 8 lines. These are the 8 lines. Now to form a parallelogram we need to select 2 lines out of these 5 lines and 2 more lines out of the remaining 8 lines. So any 2 lines out of these 5 and any 2 lines out of these 8 parallel lines will result in a parallelogram. So we can say that the number of parallelograms that can be formed here will be equal to 5C2 into 8C2. That is selection of 2 lines out of these 5 parallel lines and selection of 2 lines out of the given 8 parallel lines. And we are going for multiplication because of the principle of multiplication. We are doing both the actions together. So hence we need to multiply these two. So 5C2 into 8C2 will give us the number of parallelograms. Now 5C2 is nothing but 5 into 4 divided by 2. Whereas 8C2 is 8 into 7 divided by 2. That is nothing but NCR, n factorial by n minus r factorial into r factorial. So this is what it results in. Now 2 into 2 gets cancelled with 4 here. So the final answer will be 5 into 8 into 7. 8 into 7 is 56. 56 into 5 is 280. So we can say that total there will be 280 parallelograms that can be formed with a set of 5 parallel lines intersecting another set of 8 parallel lines. So these are some of the typical questions that are based on combinations. So that's all from permutations and combinations. Practice well on these questions. It's all about deciding whether the given question is based on permutations, that is arrangement, or combinations, which is selection. Once we properly decide and then follow the condition given in the question, we can easily get the required answer. See you in the next session. Thank you.